everyone. Welcome to Azure Serverless Conference.
Welcome to Azure Serverless Conf.
Welcome to Azure Serverless Conf.
My favorite part about serverless technology is that it's so easy to get started.
My favorite part of serverless technologies is the ability to be productive without having to worry about all the underlying bits and pieces.
My favorite part about serverless technology is that I can get started super quickly and I only pay for what I use.
Just let me write my code, build my integration, spin up databases, and Azure, you take care of the rest.
My favorite thing about serverless technologies is no infrastructure maintenance.
You don't have to think about compute or storage. You just get started and start building your apps.
I am looking forward to connecting and engaging with our community and all of the viewers that join us today.
I'm looking forward to hearing from people all around the globe about what they're doing with serverless and seeing what I can learn and make my applications even better.
Over the next 20 hours, we will have some fantastic live sessions showcasing many of the serverless technologies available in Azure, as well as a host of sessions you can watch on demand.
Enjoy the event.
Enjoy the event.
Enjoy Azure Serverless Conf.
Hello everyone, and welcome to Azure Serverless Conf. I've just had to check to make sure that my microphone was working. I'm going to assume it is. Give us a nod if you're there, Rahul, and you can hear me.
Yep.
My name's Aaron Powell, and I'm one of your hosts today. I work for Microsoft. I'm part of the developer or the cloud advocacy group here, and I'm excited for the kind of content that we've got today. We've got a heap of different speakers that are going to be covering all different aspects of serverless technologies, from the code side through to databases and everything in between. But I'm also joined by my friend here, Rahul, who is going to be helping me with our hosting duties. Rahul, say hi to everyone that's watching on the stream and introduce yourself.
Welcome everyone to Azure Serverless Conf. My name is Rahul. I'm a Microsoft Azure MVP and a group product manager at Logic Monitor.
So we've got a big lineup of sessions, and if you're joining us for the first time today, this is one of 3 streams that we've got happening over the course of about the 20 hours. We've already had the America stream where we had a bunch of content, and those sessions will be available on demand afterwards. Later on this evening, Australia time, time zones are hard. It's like, it's fine for me now, but later on, it'll be there'll be a stream happening for the Europeans. So feel free to jump on for that. There's also going to be a bunch of on-demand sessions that will be available on our YouTube channel after the fact. But enough of me talking. You didn't come here to hear from the 2 hosts. You came to hear from some speakers. So I'd like to bring our first speaker up, and we'll introduce you to. There we go. It's connected. We'll introduce you to Anna. Anna is she's a data scientist and database fanatic. She works as a program manager in the SQL Server team here at Microsoft, and she's going to tell us all about things that you can do with SQL Server, Serverless, Azure Functions, Logic Apps, and kind of everything in between. I'm really excited to hear about this because I love to see how databases can work in a serverless environment. Anna, welcome.
Awesome. Thanks so much, Aaron. I'm super excited to be here joining in from LA. I think probably a lot of people are joining in from a different time zone, and I definitely agree that time zones are hard. But thanks so much for having me on the show. I guess we can get right into it. Okay.
I realized
All
I
right.
muted myself. I was the first one to not be mute themselves on the stream. Excellent. It's off to a good start.
You might be the first, but you won't be the last. So great. Let's get right into it. So today I'm going to be talking about catching the serverless bus. So this is going to include Azure Functions, Logic Apps, and Azure SQL Database. And since we don't have a ton of time, I'm going to get right into it. So you might be wondering, oh, catch the serverless bus, but actually that's what this scenario is about. So let's go back to a day where we went to the office regularly. Maybe some of you are, but I am not. But let's think about that scenario. So typically you want to catch the bus. What happens? One of 2 things. The first thing that happens is either you get to the bus stop, you have to wait, then you catch the bus and you get to the office. Or more often than not, for the case of myself, is you get to the bus right as the bus is leaving, then you have to run to the bus, but you miss the bus, so you have to wait for the bus, take the bus, and get to the office. So this is like less than ideal. So a colleague and myself, Davide Mauri, we said, okay, we all, or like a lot of us have phones. What if we could use our phones to kind of track our location and track the location of the buses, and then get some sort of notification when the bus was close by, and then catch the bus without having to wait for the bus, without having to run for the bus, and then go to the office. And that's kind of the ideal scenario. So this was the scenario that started it all. And just to kind of give a sneak preview of where we're headed, it turns out that a lot of bus counties actually release this data publicly. So this is the King County metro area. So that would be like the Seattle, Washington area in the United States. And they have a real-time bus feed that releases this like JSON document that contains all the buses for all the routes in real time for the Seattle, King County metro area. So that's kind of the scenario that we're going to be exploring today. And we're going to go really fast. We're going to focus on the demos because I think that's a little more exciting. But just know that everything we do today is available in a learning path on Microsoft Learn. Great place to learn. And the best part about Microsoft Learn, in my opinion, is that it has this free built-in sandbox. So you're going to see every demo that I do is actually in the form of an exercise. And you can kind of spin up these sandboxes a bunch of times a day for like 4 hours at a time. So you have lots of free resources to kind of play around with all of these different things. So definitely check out Microsoft Learn and the learning path, which we're going to fly through today. But you can see each piece kind of touches on the database, the API, the app, and then putting it all together with GitHub Actions. So let's get right into it with creating a foundation for modern apps. And to me, a lot of times this means selecting the backend database service. So when we think about the backend database service we want for this solution, we're going to think about the all-up solution requirements for each piece, and then we're going to think about the specific things related to that piece. So all up, we want a website for monitoring real-time bus locations. We want notifications when a bus is close by, and we want deployment automation so that as we improve our application over time, it's a very smooth redeployment, like a CICD type of pipeline thing. Now, when it comes to available data, we saw that JSON data, you saw it just a little bit earlier, and we're also going to have a flat file that's available to us that contains some route information. If you think about someone using this application we're going to build, they're not going to want to monitor all of the routes. They're only going to want to monitor the routes related to where they're trying to go. So that's the idea. Now, when it comes to selecting a modern database for your application, even if we abstract away from this specific scenario, like a lot of times it comes down to, okay, you really want to pay for what you need when you need it. You've been hearing about this serverless hype, but can it apply to databases? You want to be able to support your development workflows, so the tools you already use, like VS Code, GitHub, Azure CLI, etc., PowerShell. You want to be able to use that. And then for this scenario and for a lot of like new modern applications, we're using a lot of JSON. We're sending a bunch of JSON, we're receiving JSON, we're processing JSON. So you need a database engine that's going to be able to support JSON in a great way. And ideally, you're also supporting some sort of geospatial capability, so you don't have to go about like importing all these different geospatial libraries and figuring out how to do that. It would be great if this database had some built-in functionality. And you also want to pick a database that isn't like too new and startup-y that you know it's going to potentially disappear in a long time. And for all those reasons, surprise, I'm from the Azure SQL team, but for all those reasons, I'm going to suggest that you use Azure SQL database specifically from the Azure SQL family, because it's going to give you those serverless capabilities and all other things you see here. So with that being said, let's get right into our first demo. So I'm going to hop back over here to the browser. And just for time's sake, I went ahead and deployed everything using the exercises. But what you can see is I have this bus database, and it's currently a serverless database. So what's nice about the serverless database is you're going to be able to set a minimum and a maximum amount of compute. We're going to auto scale you in between the exact max of what you need at a given time. So you see the min and the max. And on top of that, we're going to allow you to enable an auto pause delay. So here I set it for 1 hour. So if no one's using the application, we're actually going to separate the compute from the storage. During that time, you'll only pay for storage, which is really going to help you save on cost. So this is a great capability, as well as the auto scaling, because you're only going to pay on a per second basis for what you actually need. Okay, so that's one piece of it. Now, the other piece of it that I wanted to show you is the geospatial support. So what I'm going to do is I'm going to hop over to Azure Data Studio. This is a SQL notebook. You might be familiar with notebooks, but we're going to get right into it. And I just want to show you an example. So here you see I have some sample JSON that looks similar to our bus data. And what's great about T-SQL is that I have this built-in capability to take in a latitude and longitude, just like we did from this kind of nested JSON. And we can store it as a geography according to a certain standard and store it as one value as a location. So if we take a look at what that's going to look like, it's going to be one serialized kind of value representing that location. Now, if we want to bring it back out to the point, to the latitude and longitude like you saw earlier, we can also use this functionality called toString, and that's going to bring us back the coordinates. Now, this is really cool kind of OpenStreetMap playground that you can use to play around and test these points. So for example, if I hop back over to that, what I can do is I can simply paste in this point and see that we are indeed, hopefully, this is supposed to be a sample bus point in Seattle. So Seattle's over here, Bellevue's over here, and the Microsoft office is right over here. So you can see the bus point is just down here. So we can see that's working pretty well. So now if I hop back to Azure Data Studio, this is great. So we know we can store geospatial values. The next thing is you might want to do stuff with those values. For example, we can use this stdistance function to find the distance between those two bus data points. We can also use this thing called a polygon. So what we're doing with a polygon is we're essentially making a shape on a map and calling it a geofence. So a geofence is useful for us in this scenario because we want to be able to identify when a bus has entered or exited a geofence so we can notify our users. There's lots of use cases for this as well, like if you're trying to find the closest coffee shop or anything like that, or doing any sort of routing, like this is going to be important to understand the geofence idea. So now we can plot this polygon, but I'm going to go ahead and skip ahead to the next step where it gets really interesting, where you can also plot a geometry collection. So this would be a collection of locations, so a collection of points, and potentially a collection of geofences or a collection of polygons. And you can do that all with T-SQL using this stgeometry collection from text functionality. And then even better, you can say, use this st_within to say, is this location within this geofence? And then we can store that. So if we take a look at the results, we have just those two right here. We can copy this and we can see that our SQL thinks this is in the geofence. So just to kind of validate that, we can hop over and see, is this point in the geofence? And sure enough, we see this bus is here. This is our geofence we're going to use for the session. And it is in the geofence, so that checks out. And if we want to check this one, which says it's not in the geofence, we can go ahead and plot that as well. And we can see, sure enough, it's not in the geofence. So this was a really quick example, but hopefully an example that helps you understand how Azure SQL Database is going to be able to support serverless, JSON, and geospatial. So if we take a look at the architecture we have so far from this, what you're going to see is that we have our buses, and of course they have some sort of IoT device that's sending this JSON and storing it in real time. This is the part we don't know yet, but we didn't talk about this, but we're also going to store that route data in the database. We can just import it in using T-SQL or Azure Blob Storage, but we're going to keep it in the database so we can do some comparisons and only track certain routes and certain geofences for our users. Now, the next step is to figure out how we're going to go get that data on a regular basis and update the data in our database. And that brings us very nicely into the second piece of this, which is serverless APIs with Azure Functions and Logic Apps. So if we go back to our requirements, we already know the solution requirements, but the API requirements are that we need to be able to get the latest data, identify buses in the monitor routes, and geofence activation. So we want to know when a bus enters or exits a geofence that a user has decided to monitor the route of. And then once that happens, we want to send some sort of notification. We'll just do email that the bus is activating the geofence and they should probably go catch their bus. So for the API service, we're going to use Azure Functions. This is a great way to accelerate and simplify your development because we support a lot of different triggers. So for this, we're going to use a timer trigger, but there are lots of other triggers as well. It's really easy, really fast. These are serverless and scalable. There's really not a lot you have to know to get started. You can just deploy these and start coding. There's lots of templates and support in the Azure Functions tools and extensions in Visual Studio Code. You're going to learn all about that today. So if we think about what we want this Azure function to do is every 15 seconds, so on a timer, we want to determine what the monitored routes are. We're going to get the latest bus data. We want to identify buses in monitored routes and activating a geofence. And for those two things, we're going to actually use Azure SQL Database because we saw that SQL Database is going to easily allow us to do that. And then finally, we want to send an email notification for each activated bus. Now, for this, I could go and code up an Azure function, custom connector to Outlook or Gmail or whatever and set this up. However, I do know about Azure Logic Apps, and Azure Logic Apps has built-in connectors, and it's this great low-code, no-code type of platform where you can kind of drag and drop things and make things very easily. So I decided, I'm lazy. I think a lot of developers like myself tend to be that way sometimes. Maybe it's just me, but this is the route I decided to go, so I want to show you what that looks like. Okay, again, just for time's sake, I have gone ahead and deployed everything, but what you can see is I deployed an Azure function using the code sample, which I'll provide at the end. I've deployed this Azure function, and it actually has one function in it called get bus data. Now, if I hook into the logs, what I'm going to be able to see is some of the real-time kind of results that are coming in. Again, what's great about Azure Functions is that I can run this all locally without deploying anything using the Functions extension. Just for demonstration purposes, I went ahead and deployed it. So what you can see is it's looking for all of the bus positions, and it found one in my monitored routes, but it didn't find any buses that were entering or exiting a geofence. So it's not going to trigger a logic app. But if it did, let's assume that it did, what it's going to do is it's essentially going to call that logic app with the bus route, the bus ID, and whether or not it's entering or exiting the geofence. And that's where this logic app comes in, because when this HTTP request comes in that contains the bus route and whether it's entering or exiting, what we're going to do is we're going to send an email. So how easy was this? I just found the Outlook connector. I added those 2 values in. Like, this was so easy to do. And then I can set up who I want to send that email to. I set it to myself since I'm the only user of this application today, but you could see how you might want to set that up for a larger application. And if I hop over to my email account, you could see the past little while, I have been getting some email updates. It is getting into the evening time in Seattle, so there's less buses coming, but fortunately we're able to see, you know, when a bus was entering my geofence, and you can see it enters in the bus information and that it's entering versus exiting. So really cool, really simple, really quick, really fast demo. But remember, everything we have, you can get hands-on after. All right, so where are we? We'll take a brief pause to make sure we're good. Okay, so we have the buses, which have some sort of IoT device, which is sending JSON data, which we're going to use Azure Functions to bring into Azure SQL Database. And then we're going to use a stored procedure in Azure SQL Database to say, okay, of the routes you're monitoring, these are the buses that are in your routes, and these are the buses that are activating the geofence. For those buses that are activating the geofence, we're then going to send that information to an Azure Logic app, which you saw, and then we're going to essentially craft that email based on the parameters like the route number, the bus number, and whether it's entering or exiting the geofence, and we're going to send an email. And so hopefully you've seen how easy this has been to set up so far. And one of the cool things, which we're not going to see a ton of today, maybe at the end if we have time I'll show you all, is that we wrote all the code for the functions and the application we're going to get to in a second in Python, Node, and .NET. So if you're looking to do it in one of those languages you already know and love, or if you're looking to kind of learn a new language and compare the code side by side, that's definitely something you can do. I didn't know a ton about Node, I still don't, but I was able to, Davide wrote the Node section, and I wrote the Python section, so we're able to look side by side and kind of see what the differences are. So that was kind of a added benefit tangent that I'll go on. But if we come back to this architecture, the one thing we have remaining is this website to track. Like, it might be useful to have an idea to like look at the application and be like, oh, there are some buses like in the general area, or like there's no buses coming towards me that I want to take, so maybe I should make a new plan instead of just waiting for an email that says, hey, you should go outside. So that was kind of the reason for having also like some sort of website, and you'll see it's very simple, but that's where we came into this Azure Static Web Apps piece of the problem. So if we go back to our requirements, we have the same solution requirements. We have most of these things. We haven't talked about the deployment automation yet, but we do have the notifications when a bus is close by. Now, for the web application, we want a simple website that displays a map with real-time buses and geofences, and we want to be able to filter based on bus routes and geofences. You know, I never checked my internet, but okay, it looks like we're still live, so that's good. All right, so okay, so we want a website displaying the map with real-time buses and geofences. We want to filter based on bus routes and geofences. Now, for this, we decided to use a static web app, and these are popular, and some of these other frameworks are growing in popularity. But the key thing about a static web app is that it doesn't require server-side rendering. Now, to be honest, I was new to most of these frameworks, don't do a lot of front-end development. But for this, Davide, my colleague, and I decided to use Vue. We've been hearing a lot about it. We want to try it out, and it is supported by static web apps. Then it comes into, okay, static web apps in general, but how are we going to host this? And for that, we decided to use Azure Static Web Apps. And I think these are really cool because it's combining the power of kind of your static web application hosting with Azure Functions. So essentially what you can have is you can have in one repository code for an Azure function, code for static content, and you can either host it using GitHub or Azure DevOps, pipelines and actions to automate your deployment. So we're kind of going to check all our boxes in one go. Now, we haven't talked a lot about GitHub Actions, and I wanted to just briefly talk about the GitHub Actions for Azure Static Web Apps because a lot of it is built in for you. The only thing you have to change when you deploy Azure Static Web Apps, it's going to take care of creating this YAML file or set of instructions file for you. The only thing you have to supply or change is where in the code your client or your front end is located and where your API is located. When it comes to how data is going to move through this stack, essentially the client UI is going to use JSON to basically call this new backend API, which is then going to execute a stored procedure and return the data from the database all the way back up the stack to the front end. And the two things it's going to take into consideration, which are important, is it's going to take in the route ID and the geofence ID. Because remember, we don't want to monitor it all. We just want to monitor the things that are relevant to our user, what our user cares to track. And the front-end application, I know I'm not showing all the code right now, but the front-end application is super easy. It's basically just calling the backend and then plotting the data on a map. So very straightforward. One thing to keep in mind with Azure SQL Database and other database providers is that the connection string changes based on the language you're using. So I just wanted to call that out. Sometimes it trips me up. I try to use the wrong connection string. I can't connect to the database and then I'm just stuck. So know that most languages have these great libraries or packages you can use to connect to Azure SQL Database, but make sure you get the connection string right. Now, what I mentioned before is that we're basically going to use that backend API to just call a stored procedure. So this is the stored procedure we're going to call to return data from Azure SQL Database. Because Azure SQL Database is kind of maintaining the state and understanding everything that's going on in the system. And we're going to be able to specify how that JSON is returned so that our application can display it very easily. All right, so final demo, we want to take a look at the Azure Static Web Apps and monitor the solution. So I'm going to go back over to the Azure portal. Again, I'm not going to show you the deployment, but it's all documented and it's all free using Microsoft Learn. But you can see here I have the Bus Azure Static Web App. It has a URL, and I can see other information related to it. And in the configuration, you'll also be able to see I have configured that connection to Azure SQL Database. And if I hop over to this application, so this is the application, notice up here I'm specifying the route ID and geofence ID. I know this application probably needs some work, but hey, it's working for now. So we have one geofence and we have all these latest bus points. So it looks like there should be some buses coming soon into my geofence and we should be getting some notifications. So that's really the app. It's really simple. And then the final thing I wanted to mention is that all of this is being managed in a GitHub repository using GitHub workflows. And you can see I have different GitHub actions set up, whether it's for the Azure Static Web Apps, one for the Azure SQL Database, so we can use the DAC pack to update the schema of the database. And then I also have different ones documented depending on what language you want to use for the Azure function. So all of it's in here, all of it's documented. Super great, hopefully fun and useful for learning about all of these things. And at the end of the day, this is what you can build. So what we added in this last step was the Azure Static Web App, which kind of combines all three of these things right here. And you also just saw how you could kind of use GitHub Actions to also deploy this Azure function and also deploy the Azure SQL Database. And we have this nice, nice mediocre website where you can track the real-time buses. This was quite a whirlwind, and you're probably thinking, wow, she talks really fast. I'm not sure if I could keep up. But the good news is, remember, this is a whole learning path. So there's 4 modules where you can take your time, you can get hands-on, you can dive deep and actually deploy all these things and play with all these things in your own environments for free. So please go check out the learning path at Azure Modern Apps at AKA. Watch our show on YouTube. Follow us on Twitter to stay up to date with what our team is doing. And Davide, myself, and a few others wrote a book last year. So if you're really interested in developing modern apps and focusing on how a database can help, that's a shameless plug there. And I think we're at time. I think somehow I managed to pull this off in about 25 minutes.
Yeah, you managed to pull it off actually with a few minutes to spare. So feel free to just keep talking because we're going to have to fill the space otherwise.
Oh, great. Yeah, I should have known. I can fill some space. did we get any questions that came in on the stream?
Yes, we did. Yeah, we had some questions come in through Pubble. I think the first one's going to pop up on the screen shortly. We'll tap the producer on the head. There we go. So there was a question about why would you choose to use SQL as a relational database to store JSON as opposed to Cosmos DB, which is more designed around storing unstructured data?
Yeah, that is a great question and not a question that doesn't happen infrequently. So we do get this question a lot. And, the classic answer that everyone hates and everyone also finds themselves giving is it depends, right? So what we say, if you're thinking about when to use Azure SQL Database versus when to use Cosmos DB, the biggest reason that should drive that decision is, are you dealing with relational data or non-relational data? What we find many times is that a lot of applications, yes, use some non-relational things like JSON in this case, but really relational can be the backbone of a lot of more transactional applications. So for this example that we went through today, you could use either. Either one is going to fit your needs. And hey, both of them have serverless options. So for me, this was just a matter of familiarity. But at the end of the day, you should really choose what the main workload is going to be. So if you really are going to be using relational workloads, you're going to benefit from tables, then things like Azure SQL Database are going to be better. If not, and you're doing, kind of this write replication or other globally distributed type of scenarios, then Cosmos DB might be a better fit. So short answer, it depends.
And as someone who did consulting for a number of years, I always like going with an it depends answer because it allows you to leave it up to the viewer to decide what was going to be the right one for them. I think we've still got another minute or two for questions. Rahul, did you have any questions for Anna before I dive in with my big sheet of them?
Yes, so we have a question from one of the audience, which is, can you please give us another example of the benefit of using Cosmos DB change feed and some other types of applications?
Sure. Yeah, and I will be honest with you all. I am not a Cosmos DB expert. My team does sit right next to the Cosmos DB team, but this might not be the best expertise for me. I can't comment on Cosmos DB change feed, but hopefully someone in the SMEs can, or if not, I will go look it up and I will let you know and I will respond in Pubble. How's that for an answer?
Yeah, sure, that works.
Yeah, we've got a couple other folks that are going to be talking about Cosmos DB, so we'll also bring that question up and see if we can't stump a few more people before the afternoon is out. I think we've got time for one more question. So I actually had a question while going through that. So I haven't played with the serverless aspect of SQL Server. From a data storage and a data usage perspective, is there any difference to like a traditional SQL Server or Azure SQL rather than using it in a serverless model?
Yeah, actually, Aaron, that's a great question. So using Azure SQL Database Serverless does mean a couple different things. So there's two things that I think are good to highlight. One is that for this serverless model, we're going to bill you on a per second basis of the max of CPU or memory that you actually need. Now, if you think about the way SQL Server works, when you start to use memory, it just kind of stays. Right? So what we had to do is we had to implement a cache reclamation system so that we could actually bring down your memory usage once your big workload completed. So that's one thing to keep in mind. The other big thing to keep in mind is that when we pause a database, we separate the compute from the storage. So we essentially shut down SQL Server. So SQL Server is not running. So when you try to connect to this thing again, initially it might fail as we then decide to spin back up the compute and connect the storage and the compute together. But what you should keep in mind is that you'll be starting with a cold cache then. So that's something to keep in mind, so you won't have like this full cache or warm cache for you available. But we found with many applications that's okay. And if it's not okay, then what they do is once the database gets woken up, they have a set of queries that they run to kind of resaturate the cache to a level that they need. So those are like the two big things I would say to keep in mind. But otherwise, the auto scaling is a great benefit. Otherwise, you're kind of paying at a provisioned level whether or not you're using it.
Yeah, and that's good to know. And I think none of us probably properly understand the technical challenges that we would have by trying to take what has been a traditional database model and turn it into a serverless design. But anyway, I think we're out of time for Q&A today. Thanks, Anna, for that really good session, giving us a good taste of how you can pull together a number of different things within inside of Azure to build a serverless-based solution. I think,
awesome. Thanks so much for having me on the show. It's such a pleasure, and I hope everyone enjoys the rest of Azure Serverless Conf.
Excellent. We've just got a short video coming up, and then we'll be back with our next speaker.
Hi, I'm Anna Hoffman from the Azure Data Product Group, here to tell you about a show I host called Data Exposed. We talk about all things data, what's new, deep dives, how-tos, and we even give you a glimpse under the hood from the people who actually build the products. We cover topics like
Azure SQL security,
running high-performance SQL Server workloads on Azure virtual machines,
migrate all your database assets to Azure SQL,
data science with something old and something new,
Azure SQL Managed Instance,
developing apps with Azure SQL Database,
and more. We post short episodes on Thursdays, and once a month on Tuesdays, we release a special MVP edition with the community.
May the 4th be with you.
Catch us live on Learn TV on Wednesdays at 9 a.m. Pacific.
Oh, we're back.
Welcome back. And I'm very happy to introduce Will, who is an MVP in the data platform space and is joining us from New Zealand, where he is building a health platform on serverless tech.
Hey, guys. Awesome. Thanks very much for having me. Welcome, everyone, to Azure Serverless Conf. So good morning, good afternoon, good evening, wherever you are in the world. Thanks for joining us. My name is Will Valida. I'm an Azure integration consultant working for Datacom and a Microsoft Data Platform MVP based in Auckland, New Zealand. Now, in this session, I'm going to be showcasing a little side project that I've been working on, building my own health platform with some serverless technologies. So this is going to be a nice overview of several different serverless technologies that I've used to build my own platform, kind of like side project. And hopefully this will give you some ideas. Say if you've got a side project that you wanted to work on in your spare time, or you're thinking of a system to improve or make your life a little bit better. Hopefully this will give you a little bit of an inspiration. So to start right from the beginning, this year was a big year because I'm starting to get old. I turned the big 30, the big 30, and I kind of had this realization that I should probably look after myself a little bit more, start to think how I'm, am I getting enough exercise? Am I eating right? Am I sleeping properly? Am I doing a certain amount of steps a day? And prior to my 30th birthday, I have a bunch of Fitbit devices that I use day to day. So I've got a Fitbit watch, which tracks my activities, tracks my step count. I also wear it when I go to bed, so it tracks my sleep. I also have some Fitbit scales, which I can jump on just to track on my weight. And I also use the Fitbit app as well to log my food. So I have all this data just sitting there. Not really doing much. I'm just collecting. It's just there harvesting my data. And I was thinking, well, how can I actually use this data to make some more informed decisions about my health? And how can I access this to actually do something useful to it with it? So, so I did a little bit of investigation on how I can actually get this data, and it's available as an API. So Fitbit, the good people at Fitbit have developed an API. And I can actually call some endpoints to actually retrieve this data, which belongs to me and that I'm generating through my devices. So it got me thinking, how can I build an application that incorporates my Fitbit data and try and use some of the technologies that I know and love and try and build something meaningful and useful out of it? So I started with just a simple piece of paper, writing up some requirements. So I thought, well, I can actually call this API on a daily basis to get last night's sleep, what I ate the day before, what kind of activity I did the day prior. I can also use the API to call to actually get a month's worth of weight data. I don't always jump on the scale day to day, but I can do that over a period of a month. So I can use the API to do that. And then I had a look at the data that when you call the API, what kind of data gets returned to you. And there's some data that I'd want to use, some data that's not so useful. So I needed to have a bit of a process where I can actually call the raw data from the Fitbit API and transform that into a schema that I could work with and that give me the data that I could actually use. And then I need to take that transformed data and then persist it somewhere. And it needs to be really, really simple. It needs to be flexible because over time, I might find that some pieces of information are a little bit more useful. Maybe I'm retrieving data and not using data that could be useful. So I need a data base or a data store that provides me with that flexibility. And then I also need a way to, once that data is persisted, I actually need a way to actually serve that data via API so I can do some visualizations on it, maybe build a little website, maybe serve that data from the data store and feed that data into some machine learning workloads, etc. So what I came up with was the following architecture. So starting right from the Fitbit API, I can use timer functions to actually run functions on a schedule to call the API. So at 5 o'clock in the morning, my timer functions start, and they actually call the API to retrieve yesterday's data or monthly data for my weight data. I also have another function to refreshes my authentication with the Fitbit API, because for those of you who aren't so familiar with Fitbit APIs, you need a way to be able to authenticate to them. So I have another timer function that actually handles that authentication for me. So it will generate a new access token that I can use, and I store that in Key Vault. And then when I need to retrieve the data from Fitbit, I can essentially get that token from my Key Vault, so I can call the API and make authenticated calls to get that data. And then I need to handle the processing of messages from function to function. So I'm using Serverless Bus to enable to be able to do that. And then I have other functions that read messages from the Serverless Bus and do a little bit of mapping from its raw data into the new schema that I want to persist, and that persists to Azure Cosmos DB. And then sitting on top of that, I've got a bunch of serverless API functions that are essentially HTTP triggers that can actually serve that data from Cosmos DB. I've also got a logic app as well that every time an exception gets raised within one of my functions, that will send a message to a Serverless Bus queue. And essentially that logic app will pick up the message from the queue and then send an email to me. So I get a little email saying, hey, one of your functions, something's bad has happened in one of your functions. You should go and take a look at it. And then we've got a little bit of basic monitoring and CICD as well that kind of orchestrates this. So I've got application insights that monitor my functions. And I'll talk a little bit about how application insights works really, really well with Azure Functions. And then for CICD, I'm using GitHub to host my code, and then Azure DevOps to manage my build and releases. And I'll talk a little bit about how that's working within this project. So why Azure Functions? I really wanted to take a code-first approach. Another motivation for actually doing this project was to kind of work on my development skills, work on my coding skills. So I opted for Azure Functions, and Functions can help meet the demand with as many instances and resources as needed, only when needed. With this pipeline, I don't need my functions to be running all the time. There's literally some timer functions that wake up at 5 o'clock in the morning and actually make calls to the Fitbit API. And then once that's done, I don't need it to be running anymore. So Azure Functions provides a really flexible way for doing that for me. Now we can write our Azure Functions using any of our favorite programming languages. So we can write them in C# like I have. We can write our functions using Java, JavaScript, PowerShell, or Python. And if we're using other languages, maybe such as Go or Rust, we can write custom handlers to author our functions. I wanted a way to automate the deployments for my functions, both the function application infrastructure as well as my code. And also I needed monitoring as well. So when things go wrong, I want to know what's gone wrong. And Azure Functions integrates really, really well with monitoring tools that allows us to gain insights from our applications. Now, in order to react to events in functions, we use something called triggers. Now, triggers are what causes the functions to run. So a trigger defines how a function will be invoked, and each function actually must have exactly one trigger. And triggers will have associated data with them, which is often provided as the payload for the function. So in my application, I'm using mainly 3 trigger types. So I'm using a timer trigger, which essentially enable our functions to run on a schedule. We provide it with an n cron tab expression, and that's when our functions will be invoked. And we're using that at a particular point in time to make a GET request to the Fitbit API to actually retrieve that data. I'm also using Service Bus as well, a Service Bus trigger type. So enabled to react to messages sent to queues and topics. We can create Azure functions that have a Service Bus trigger to be able to process messages that are sent to our Service Bus queues and topics, which is what I'm doing within my kind of Fit Health platform. So whenever a message is sent to a Service Bus, I can actually read a message off the topic. And then we also have, I'm also using HTTP triggers. So essentially we can invoke our functions via HTTP requests, but we can also use HTTP triggers to respond to webhooks. And I'm using that with a bunch of serverless APIs that I've developed to make GET requests to actually retrieve the data that I've persisted into Azure Cosmos DB. Now, with functions, there's a huge amount of support for a variety of different triggers and also bindings as well. So this is a very small subset that I'm using. We can create functions that get invoked due to events happening in Event Hub. We can have Kafka support. There's really quite a lot of different variety of triggers that we can use within our applications. And there's also a lot of flexibility in how we host our functions. Now, in my scenario, things are only really happening. It's very low burst traffic that's actually happening within my function application. Really, it's only 5 o'clock or 6 o'clock in the morning, something happens, and then for the rest of the day, they just sit there idly. And then for that, we can use a consumption plan. So we can only pay for our functions when they run, and there's automatic scaling. So they scale up to as many events as we need it to, and that's all handled for us. Now, depending on what kind of workloads you're going to be processing, there are a variety of different hosting plans that you can use for your Azure functions. We can go up to premium, which is the next step up. So essentially, there are pre-warmed instances. With consumption plans, you can scale right down to 0 instances, but that can cause some latency through cold starts. In premium, this is not the case. You can actually have pre-warmed instances, which will run applications with no delay after being idle for such a long time. It also runs on more powerful instances, and you can also connect it to virtual networks. And you can have a longer execution time with your functions than you would with consumption. You can also host your functions on dedicated plans. So if you have an app service plan, you're not really utilizing the underlying VM, you can actually deploy functions to it. And there you can have some predictive scaling and costs, and also utilize the VM if it's being a little bit underutilized. There are also more isolated plans, so you can even run your Azure functions on app service environment, which provides you with a fully isolated and dedicated environment for secure network access. Or you can actually host your Azure functions on Kubernetes, either directly or on Azure Arc, which provides you an isolated environment for your functions, but running on Kubernetes. Now, that's not to say that Azure functions are the be-all and end-all as part of this platform. some of part of our workflows need to be straightforward. It's a little bit more simpler to develop some parts of the application using logic apps. So within my platform, like I said, I have a single logic app that essentially sends exception details from functions to me via email. This came about because I was really messing about with the SameGrid API in Azure Functions and trying to get it on an Outlook.com account, which is a little bit more frustrating and didn't quite work as well as I expected it to. And what Logic Apps provides is a large collection of connectors and actions that we can use so we can build highly scalable integration solutions, and we can connect to a variety of different systems, whether they be legacy or modern systems, really, really simply. And I'll show you how I actually used Logic App to process those exception messages and send them to me via email. Moving to our data store, Azure Cosmos DB. So Azure Cosmos DB comes with a serverless offering, and it lets you use your Azure Cosmos DB account in a consumption-based fashion, where you're only charged for the request units that you consume by your database operations and storage consumed by your data. So for those of you who aren't too familiar with Cosmos DB, before the serverless option, we would have provision throughput. So essentially, whether you're provisioning throughput at the database or container level, you would provision your throughput, allocating so many request units per hour. And regardless of whether you're performing operations against that or not, you were charged for using those request units. But the difference here with serverless, we don't actually have that. We're only charged for what we used, so there's no capacity planning required, and it can serve thousands of requests per second with no minimum charge, and again, no capacity planning required. There are some differences. So some of the limitations are with Azure Cosmos DB Serverless, you can only have a single region. It's not possible to add additional Azure regions to a serverless account once you create it. And it's also not possible to enable the serverless link. So if you're using Azure Synapse to run some analytical workloads on top of your Cosmos DB data, you're not able to do that using Cosmos DB Serverless. But one of the big appeals of using the serverless option for Cosmos DB, Cosmos DB serverless best fits scenarios where we expect intermittent and unpredictable traffic with long idle times. Like I said, I'm only really performing work in the morning. So this functions will get triggered at 5 a.m. in the morning, and I'll persist to the database around that time as well. And then for the rest of the time, there's nothing really going on. There are a couple of GET requests to retrieve the data out of Cosmos DB, but it doesn't really justify provisioning throughput on an hourly basis because it's not required, and it's also going to cost quite a bit. So if you're thinking about using, if you're tossing up between using serverless or just continuous provision throughput, if you're just getting started with Azure Cosmos DB, if you're running applications with bursty intermittent traffic that's really hard to forecast and it's quite low, the amount of traffic that's actually hitting your database, or even if you're just developing or testing or running prototype applications or running in production new applications where you're not quite sure where what the traffic will be like, I'd really recommend using Azure Cosmos DB Serverless rather than opting for provision throughput. And what I'll do is I'll just step into the pricing calculator. So essentially what I've got here, I've just set up a serverless, or just entered in a serverless database for Azure Cosmos DB. And then in Australia East, which is the Azure data centers closest to me, per 1 million requests, you get charged 43 cents New Zealand dollars. I do apologize. If you're not too, I don't know what the exchange rate is. But if I have a gigabyte of transactional storage, I would pay 87 cents a month based on the, if I was hitting a million per 1 million request units. However, if I switch this up to a standard provision throughput with a single region right, with Australia East, so I've got 400 request units per second for a 31-day period, I'm paying $41.40. I've also got storage costs as well, which is still relatively low, so it's 43 cents. But here I'm paying $41.83 per month, which doesn't really make sense. If your traffic is really idle, you're essentially just burning money on throughput that you don't need. So if you have an application that doesn't have a lot of traffic, I'd really recommend going with the serverless option. And then monitoring, we need a way to actually see what's going on with applications, just in case something bad happens or an exception is thrown. We need a way to be able to actually diagnose what's going on within our functions. And the really cool thing here is that Azure Application Insights, Azure Functions offers built-in integration with Application Insights to monitor our functions. So Application Insights will collect, log performance and error data, and then by automatically detecting performance anomalies, and you can use analytical tools, you can actually diagnose issues that occur within your function applications, and you can actually understand how your functions are being used, and you can actually see dependencies between your functions and various other components within your architecture, which I'll show you in a little bit. And this really helps us to continuously improve the performance and usability of our functions. And we can use application insights locally as well when we're doing development. So it's a really powerful way of getting insights into your Azure functions. And then we can also use our favorite CICD tools for our serverless applications. So for this particular project, I wanted to kind of boost up wanted an easy way to boost up my GitHub stats. So we can actually host our code on GitHub. And what I've done is I've also implemented my build and release pipelines on Azure DevOps. I didn't think of using GitHub Actions at the time, but you can do a bit of mix and match with GitHub and Azure DevOps. We can enable this using service connections. So I've actually created service connections to GitHub, to Azure, so I can actually incorporate my CI/CD process through Azure DevOps. And you can also use YAML multi-stage pipelines for your build and releases. And here, I've also used Terraform to actually provision my infrastructure. For this, I've used classic release pipelines, but you can also achieve this using YAML pipelines as well. So that's a lot of slides. So what I'm going to do now is we're just going to go through a very quick tour of the application. I'm going to show you all these moving parts. So this is Application Insights. So essentially what I've got is I've got this single Application Insights namespace, and all of my functions are admitting logs to this central location. And what I've got here is an application map. So essentially, I've set this to the last 12 hours because this all happened early this morning. But essentially, what we can do with this is we can actually see at a very high level what our dependencies are between different components within our architecture. So I can see here, I've got my authentication service that refreshes my token. And that's interacting with my key vault, and also interacting with or making calls to the Fitbit API. And here, from here, we can actually investigate the performance of the calls. So this is a function. We can actually investigate a function within my function application. We can investigate the performance of that app there. We can also see any failed dependencies. I can see one there. And we can view this in logs if we want. But so that's so those are my functions at the high level. So what I'm going to do now is just go into my function code. So essentially for activity data, my weight data, my food data, etc., I've got a similar pattern going here. So starting off, we have a timer trigger function. This kicks off at 5:15 in the morning, New Zealand time. You can actually set the time zone as part of your, set the time zone on your function application. And this makes a call to the Fitbit API and sends to this topic here. So this activity topic that I've got. And if any exception gets thrown, it gets sent to the exception queue. If I go into this function here, this is where my document gets created. So what it will do it will read read the message that's been sent from. It will read the message from the topic, essentially deserialize that into a schema that I've formatted or that I want to persist to the database, and then it will persist that activity document to my Cosmos DB account. And then finally, I've got a function here that I've got a couple of functions here that can actually read the data from the database. So that's just a very high level from point A to point B, right from calling the Fitbit API, persisting it to my Cosmos DB account. So if I go back here into, so this is my app service plan. So this will be a dynamic plan that I've got. I've got all my applications running on Linux. We can deploy our functions to either Windows or Linux. I've chosen Linux. And this is these are basically all the functions that are sitting within that application plan, or app service plan, sorry, which you can create using either Terraform or Bicep or ARM templates. I've opted for Terraform because I was using Terraform quite heavily, but you can also use Bicep as well. So here I'm just creating a dynamic Linux app service plan. And then I'm also provisioning my Azure Functions using Terraform as well. So I'm importing my app service plan. And then when we're actually creating our function application, we can say, oh, okay, deploy it to that particular app service plan that we've imported into our Terraform file. So if I just go back, so here's one of the functions that I've created. So we can see there's the app service plan that it's deployed to. If I go into my functions there, I can see I've got this single timer trigger function that I showed you earlier. And here we can see past invocations from the monitor here. And we can also run this query in application insights that we've connected this function to. My recommendation, if you have a bunch of different Azure functions, try and make them, well, use only one instance of application insights. And with this, we can configure deployment slots, check configuration. If you're using managed service identities, I haven't enabled it for this function, but you can actually, oh, I have. You can actually use MSI to connect to different services in Azure. So this one is actually connecting to Key Vault. We can also configure availability tests. So essentially, this will just be like a URL health check that will ping every so often just to make sure that the function's healthy and ready to go. It looks like it's passed the last one. I'm just looking at the time, make sure I don't overrun. But I've also got this serverless Cosmos DB account. So here, I'm petitioning by document ID. As you can see, I can't deploy other regions as part of this account. But I've also got the serverless capacity there. And we can incorporate some CICD with this as well.
Sorry, I'm going to have to just jump in there for a second, Will. Like this is really exciting. I'm loving the detail in the way that you set up application insights and the mapping and everything through it. But we are running a bit out of time. There's been a few questions that have come in, but unfortunately we're not going to have time to get to them today. But for those of you that have been asking the questions on the Pobble chat, don't worry, we'll get to them and answer them back there for you. But yeah, just to finish off, Will, is any closing remarks, or do you have any links to share with the audience?
Yeah, so for the code, I've got it all hosted on GitHub. So there's my GitHub account there. Just basically github.com/willvalida. Just search for my health, and all those different repositories are essentially the code that I've got for this for the project. Yeah, also feel free to connect with me on Twitter as well. I am in New Zealand, so the time difference, I may be delayed in getting back to you. But yeah, just takeaways, hopefully in that kind of like that basic demo that I showed, that it basically, with the serverless technologies, you can actually build something really simple, really straightforward, but add layers of sophistication as required. So it can be anything ranging from a simple like basic project from A to B, but you can also add layers of sophistication such as CICD monitoring and really scale up your application depending what you're trying to achieve.
Excellent. Sounds good. We've just got another short video and then we'll be back with our third speaker.
Up until now, the problem with building applications has been that before you could even start, you had to choose a framework, learn how to deploy that framework onto servers, then manage and maintain those servers over time. Not exactly easy, quick, or efficient. Thankfully now there's Azure Functions, the easy way to build the applications you need using simple serverless functions that scale automatically to meet demand. No worrying about infrastructure or provisioning servers. Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs. See for yourself at functions.azure.com and try it, free. You'll see that making applications has never been easier with Azure Functions.
We're back. We've got another one of our New Zealand friends is going to be joining us in a moment when they pop up on the screen. We've got Wagner is joining us from New Zealand again, and he is going to be talking to us about Logic Apps, which I think is a massively underrated technology. So I'm really looking forward to getting some new ideas of what we can do with Logic Apps. Wagner, over to you.
Thanks, Aaron. So let me set everything here and ready to go. Welcome, everyone. My name is Wagner Silveira. I'm a digital integration practice lead at Tita and Microsoft Azure MVP. And what I'm going to try to show here in the next 25 minutes or so is some new scenarios with Logic Apps. So let's go through the agenda and see what I'm going to try to discuss. So the first thing is I'm going to be talking a little bit about identity-based authentication. There is a couple of things that came up with in the last year or so that not everyone is taking in consideration. We're going to be talking about state versus speed, like when to use some of the new features that came with Logic Apps Standard. We're going to talk about the concept of Logic Apps Anywhere. And then finally, something that is was a big problem with Logic Apps before, that is private network integration. At the end of that, then I'm going to try to give you some takeaways for you to think about when you finish the presentation. And in some of those, I'm going to have a demo, so started helping me to pray to the demo gods. So let's start with the identity-based authentication. So on that, what is the story so far? Basically, if you're thinking about inbound, when you're trying to get into Logic Apps, there was only one way for you to authenticate, and was sharing keys. So you have like that big or massive URL to access your Logic Apps, and a part of that would give you some share keys, right? If you're thinking about going out of Logic Apps into all of the things that Will and Anna talk about, the ability to have a lot of connectors, and that's actually one of the great value propositions for Logic Apps. But there is two things that was usually a problem here. One is the identity was always associated to the connector itself, and as a connection, right? And there is a named account or connection string. So there is no way to identify the Logic Apps as a user. Instead of that, you have to put like a service account or your own account to make sure that worked. So what is new on that? There is two things that is really, really interesting. When you're thinking about inbound authentication, we have the ability now to do OAuth-based authentication with the logic apps when you're trying to do a request to that logic app. And when you're thinking about outbound authentications, now you have the ability to create a managed identity for logic apps and use that to authenticate against some of the connectors, right? So how that happens? The first thing that we can do is there is new authentications options on the consumption, on the logic apps consumption that are going to be showing. And also there is new managed identity options in some of the connectors for both consumptions and standard. So that is like a lot of things that we didn't thought much about before, but we didn't have a way to use before, and now is available on logic apps. Let's take a quick look on that first one, the logic apps inbound authentication using OAuth. So I'm going to change it back to my Azure here, right? And what I'm going to show you is, first, let's take a look at logic apps. And inside that logic apps, we have now this option called authorization that was not here before, right? So when you look at that, now you have the ability to create one or more policies for the logic apps to say to receive an JWT token and evaluate the JWT token and say, if you receive the information with those claims, you can get inside. Otherwise, you're not able to. The demo that I have for you is this. I'm going to show you inside the API management. We have an API called Azure Serverless Conf with a single method, right? But on this method, what we're going to be doing is, as I go into the logic apps, I actually setting I'm in the right one, yes. So I pass in a record with my MSI access token, right? I'm actually creating my authentication, the managed identity, calling a specific logic app application, enterprise application, putting that information on that MSI access token if it's valid, and then I pass in that as a bearer token authorization into the logic apps. So let's see if that actually works. So if I go to Postman, I have here first the call to that endpoint, right? And you're going to see that the headers that I'm passing to that endpoint, I only passing the OCPA ping subscription key. That is the share key that you needed to authenticate against API management, not against anything else, right? So if I go and call that, and the demo gods are with me, I'm going to receive a very complex response. Let's see what's happened. There we go. I receive a very complex response called hello world. That means that the logic apps is actually being called, and you can say that happening. We have a call at 5:09 p.m. New Zealand time, right? And that basically execute my hello world. But if I try to call that same logic app now directly, even with a valid, what seems like to be a valid token, let's see what happens. First, I have a security token expired, right? So one, it identified that I'm trying to pass a token that is not valid. Just make sure that you guys can see that. Okay, but that's fine. That can be fixed. Let's try to get a new access token. There we go, we have a new access token, and I'm going to be using that one, and I'm going to be sending that. on that token, because it didn't come from the API management, that was the only item that I'm allowing to go through, it received an error. And you can see that prod01 logic apps 2F28, just to prove there is nothing on my sleeve. And if I go to my trigger, it didn't even execute it here because it didn't access. Right, I just wanted to find my trigger definition here. Let's forget about it because I don't want it to spend time. I just wanted to prove that that logic app is the logic app that is being called. But just to recap on this, right? Authorization is something that you now is able to implement using and take advantage of JWT token instead of taking advantage of just the shared connections, right? Let's go back to our presentation. Let's talk a little bit about the gotchas on that, because you always have some kind of gotchas, right? So the first one is inbound authentication is not available on Logic Apps standard yet, right? So you needed to take that in consideration. You can disable shared access keys even though you're using the authentication, the OAuth authentication method. If you get hold of the share keys, you still should be able to call that logic app. And if you pass a logic app without the share keys and the authorization, it is going to complain about you don't have some share keys, right? So there is no operator on policies. You see that I only had like this equals that, right? There is no option to say if that claim contains something. And just to complete, although we didn't look at a managed identity because we're not going to have time to go through everything, managed identity is only going to be enabled for selected connectors, right? So when you're looking into the connectors, try to take a look if managed identity is available, and if it's available, try take advantage of that. It's going to make your system much easier to manage because it's going to be passwordless and more secure. All right, so let's go to the next scenario. Let's talk about state versus speed. So what is the story so far? The first thing is there was only a single model for Logic Apps. When you're looking at Logic Apps consumption, for example, there is only one model, and the model is state is king, right? You always have a state on each one of the connections. What that means, everything that is like a before and after an action on Logic Apps, that state is kept. And that is really good from one side because allow you to connect to knows exactly what's happening inside Logic Apps, something that we sell as one of the big advantage of Logic Apps. But on the other side, all of that auditing take a toll in terms of performance. And there is only so much optimization that you can do, right? So you can combine actions, you can try to make things more condensed to avoid to put like that much pre and post authentication, but you can only do that so far. So what is new on that? Well, the first one is you can choose a model now that is closer to your requirements, right? There is 2 models available on Logic Apps compared to just the stateful model that we had before. And the first one is the stateful workflow, And on the state mode workflow, what you have is the ability to have full auditing to everything that happens on your logic app. You have, like, for the trigger, what happens, what initiated the trigger, what is the result of that. For each one of the actions, what was the inputs for that action, what is the outputs for that action, right? That makes your troubleshooting incredibly simple, because you know exactly where it fails and you know the data that makes it fail. It also gives you a lot of support on your resubmission. Since you have the inputs that trigger your logic app, that means now that you can resubmit your logic app from the portal or from the engine itself, instead of having to receive a request again to initiate that. Then you have the stateless logic apps, right? What is the advantage of that stateless logic apps in this case? One is a lot more throughput, right? Because since you don't have that the burden to have to audit everything, you're going to be able to run those things faster. You also have an advantage here from a cost point of view. With Logic Apps Standard, now you're paying for both the engine running inside an environment that just like Azure Functions, but also you're paying for the storage to store all your metadata or auditing, right? You're paying for the in this case for your storage account. So if you're using stateless logic apps, you have less things written on that storage account, so you're paying less, right? And also have ability to privacy. One of the things that was really people really complain about logic apps is, especially when you're talking about private data, was you have to go to every single action inside the logic app and select which action that action has secure inputs and outputs, right? So you needed to remember everywhere the data that was supposed to be private and shouldn't be seen even by the people that is managing and supporting the logic app. You needed to enable that the input and secure output for it to be obfuscated or to be encrypted, so the people that is supporting wouldn't have access to that. With the stateless logic apps, because that is not being implemented by default, it is not being audited by default, that information is not there, and you needed to force to actually enable that for debugging. So how is that working, right? What does that creates that magic? The first thing is what it's doing now is the new models on Logic Apps Standard. If you needed to use stateless Logic Apps, you needed to implement that on the new Logic Apps deployment model that is the Logic Apps Standard. The Logic Apps consumption doesn't have that option for you. So stateless Logic Apps is going to give you high throughput. You just needed to remember that. And stateful logic apps is going to give you high resilience, so auditability is going to allow you to actually resilience in this case, the ability of submitting messages without the requirement of your your source having to send the trigger again, and auditability from the point of view that you know exactly what's happening on each one of the actions. But as everything, there is some gotchas on that, right? So the first thing is stateful or stateless needs to be a design decision. And the reason for that is because each logic apps only have a single state. And although in theory you should be able to change that states, not everything that is available in stateful is available in stateless, right? So for example, you have managed connections with triggers from managed connections. You don't have all of them. You only have the HTTP requests and the timers. And variables, those are the two things that I notice are not available in Logic Apps stateless, right? You can always use the compose action to manage variables. That's what we used to do before, right? But you're not able to use variables itself. So this is the second state, right? Let's take a look at the next, the second scenario. Let's take a look at the third scenario. That is Logic Apps Anywhere. So what is the story so far? The first one is the only place we could deploy Logic Apps was on Azure, right? And you were bound to a resource group. So you have a Logic Apps bound to a resource group and existed by itself. It didn't. It was not something that you could combine together and deploy as one package for something. Your boundaries or your package was a resource group. And how it's done today? What is different today? So first, you have now a choice of deployment. You can deploy the Logic Apps by itself, or can deploy the Logic Apps as a group of workflows if using Logic Apps standard. That means that now you have the choice of the packaging, right? You can deploy as a set of ARM templates, or you can deploy as a package based on web apps format or functions format using the Logic Apps standard. And also you have the choice of compute. You can deploy on Azure using the consumption engine. You can deploy on Azure using the serverless or the BAS component based on Logic Apps standard. And you can deploy on any other cloud or on premises. How is that happening? With the introduction of Logic Apps standard, now you have the ability to deploy either using the PaaS or using the containers, right? So if you wanted to use Logic Apps by itself, you can do that using Logic Apps consumption. If you wanted to use Logic Apps as a group of workflows that represents an application, you can do that using Logic Apps standard. And if you wanted to deploy outside Azure, you can use Logic Apps standard package as a container. If you're running that on premises, you can use run either inside a Docker server, or you can run that using a Kubernetes server. And if you wanted to run on any other cloud that's not Azure, or even inside Azure, you can use Kubernetes. So what are some of the gotchas of that? First, you needed to choose your storage, right? And depending on where you put in that information, you might have like differences on how that's going to work. Right now, for your Logic Apps standard, you only have the ability to deploy that on the Azure storage, but the SQL Server as a storage is starting to become available, and there is a preview for that. Second thing that you needed to think about is your management plane, right? So if you're running that on Logic Apps, that is on Logic Apps standard, and you deploy in Kubernetes, you needed to find a way to integrate to see the management plane. And the way that that's working today is by using Azure Arc. So you should be able to see your Logic Apps like it was running on Azure, and because of that, you would be able to see and manage your Logic Apps. And you needed to take a consideration built-in versus managed connectors. Managed connectors is still going to require Logic Apps, a resource group for that to be deployed. And when you're talking about managed connectors, are the connectors associated to Azure. So finally, let's talk about private networks. So one of the problems that we have with Logic Apps before is you only have outbound integration, right, for private networks. And that was based on-premises data gateway. So you would only be able to actually connect to either a private network or on-premises using on-premises data gateway. And then was kind of on-premise data gateway is very broad brush, right? It needs to you open a pipe into that network, but you don't have much control. So what is new? Outbound and inbound integration is available now, right? You'll be able to define if you wanted to have integration from your logic app, from your private network into the logic app, and logic app into the network. It's much more focused because now you're able to actually define exactly what is going to be integrated. And how is that working? Again, using the logic app standard, because logic app standard is based on the functions engine that that is based on the web app framework or the web app engine, you're able to leverage from outbound options like VNet integration and hybrid connections. So you also have the ability to have inbound options with the private endpoints, right? But let's actually take a look at that instead of just talking about through a little demo. So just going to jump here quickly because I can see that we're getting really close to that. What I'm going to show you on this one is on Logic Apps Standard, although that is a Logic app, right, with its own workflows, a couple of workflows, right? I have now the networking ability. And on network, I have the ability to do inbound traffic by access restriction, by app assigned address, or by private endpoints. And for outbound traffic, I have the ability to do VNet integration and hybrid connections. Okay? So I run a really quick item here. I'm going to show you that this is actually going to the Logic Apps Standard and just going to insert this item here. The demo is working. Here is the proof, right? You can see that this is actually running on my laptop, and I have those 3 entries. Now I'm going to execute the same thing from going to the Logic Apps Standard that is going to connect to the hybrid connection and call my SQL Server. So let's see if it works. So first comment, this is a demo for Azure Serverless Conference. Anonymous is saying Wagner is cheating. Sorry, I'm not. And then me saying, no, the demo is working. Here is the proof. All of that, although looks like a really simple demo, went up to the Logic Apps via hybrid connection, call the SQL Server inside my Logic Apps and come back. And using hybrid connection, that means that I'm not able to open everything, just that particular IP and port. Let's go back to this session. What are the gotchas on that? The first is you needed to understand that that's going to be only for selected connectors, right? There is some built-in connectors that are able to use the VNet integration. Those built-in connections are grow on time, but just take that in consideration when you're thinking about how to use the Logic Apps virtual network features on standard. Then finally, let's go to the takeaways. So the first one is obvious. Now with Logic Apps open a lot of new scenarios, right? And now with Logic Apps Standard, you're able to create workflows, but bring it really close to app development. Before it was, is this thing on the portal that you have to develop, and then later on has a lot of ways, a lot of work to actually deploy. now is something that is together with your development environment of choice, packaged just like an Azure function, deployed just like an Azure function. But just remember that there's still a new technology, right? So there are some gaps that might affect your design. So make sure that you understand what are your choices and to see how it's going to work properly, but also don't discard consumption, right? Just because Logic Apps standard is there, that means that the consumption is not part of the puzzle. It is still something that is quite useful. And that is me, right? If you wanted to connect with me, you can go to the connected through my Twitter, or send me a message on my personal email, or connected to my blog post.
Thanks, Brandon. That was really great. I'm someone that thinks that Logic Apps is a technology I need to learn more about and never invest the time. So I love seeing demos like this and just how easy it is to use as a stack or as a tool in our toolbox. And that hybrid connection stuff that you showed at the end, super powerful because it just makes it so much easier if you're doing hybrid application design where maybe you're not ready to put everything in the cloud, but you can still use the power of the cloud there.
Cool.
But
yeah, it was like it's something that is really interesting in with the Logic Apps standard now. Is growing a lot and is going to get much closer to developers. So we should be hearing a lot more about Logic Apps, even more than what we saw before.
For sure. But unfortunately, we're out of time for questions with you today. Check out the poll again. Keep popping those questions in there for our speakers as we get to them. But next up, we have another speaker. We're going to keep rolling through them today. No rest for the wicked. And we're being joined by Melissa. Melissa is a senior lead developer. I wrote this down. I knew I was going to get it wrong. Down in Melbourne. She also is one of the organizers of the .NET user group and a Microsoft MVP. But today, she's going to be talking about something that I love, JavaScript and Azure Functions. Melissa, welcome.
Thanks for having me. And thanks for everyone for tuning in to the Azure Serverless Conference today. So my talk is called JavaScript in the Cloud, and really it's a high-level look at all the cool stuff you can do with JavaScript on the cloud, specifically in Azure. My socials are up on the screen if you'd like to connect with me. I love to connect with people who have similar interests to mine, so please reach out. A little bit more about me. So as Aaron said, I'm a lead software engineer at a company called Xenix, and I'm a Microsoft MVP in developer technologies. I mainly work in application development focused around .NET and worked a lot with Angular and other JavaScript frameworks, and also have been working quite a lot in Azure. And when I've been doing my more recent learning about cloud computing and Azure, I was surprised by how much you could actually do with JavaScript in the cloud. So I put together this talk. So what is the cloud? We know that it's software and services that run on the internet instead of locally on your computer. In a big data center, usually run by Azure or whatever cloud provider you're using. And you rent that space and pay for what you use, letting it scale as your business needs change. While cloud providers like Azure take care of managing that physical infrastructure. So really, there is no cloud. It's just someone else's computer. And the other part of this talk is JavaScript. So JavaScript is a lightweight programming language that allows you to implement complex features, usually used for web pages. It runs natively in the browser, and many people, when they start programming today, start with JavaScript. And this is because it's relatively easy to get started, and since it runs in the browser, it's quick to get up and running. And my first experience with JavaScript actually started with this O'Reilly book. I'm not sure exactly what the edition was at the time, but during my university degree, I didn't actually learn any JavaScript there. It was in one of my first jobs in the tech industry while I was still studying. I started at the software solutions company, and I was told that we were using the main stack, which is Mongo, Express, at the time was AngularJS because the newer version didn't exist yet, and Node, which is all JavaScript-based frameworks for building end-to-end full-stack applications. So I was handed that JavaScript book, and after reading it, trying to understand what the heck a closure was, I was partnered with a senior to do web development. And from there, I've used JavaScript mostly throughout my career focused on web development. And traditionally, JavaScript is a language for the web. It was created in 1995 in just 10 days by Brendan Eich, who worked for Netscape. It was created as a scripting tool to manipulate web pages in the Netscape Navigator browser, and soon after was standardized and took off to become one of the most popular client-side programming languages, with today 97% of the web using it. However, JavaScript is much more than just a client-side programming language. It was also initially created to be used on the server side, but didn't become popular as a server-side language until later on with the creation of Node.js in 2009. So Node.js is an open source, cross-platform, backend JavaScript runtime environment that runs on the V8 engine and allows you to execute JavaScript code outside of a web browser. And with the advent of Node.js as a popular server-side JavaScript programming language, it opened us up for the ability to use JavaScript in the cloud. And I personally am a really big fan of simplifying the developer experience and using one language end-to-end across your application. And so with the use of Node and all these other JavaScript frameworks that we know and love, it makes it really easy for developers to work across the full application. And you don't have to have this separate front-end, back-end team specialists. You can have all the skills you need to build the full, robust applications and having some of the same toolkits that you're used to working with different parts of your code. And with Node, we can now run our JavaScript applications on the server. And if you look at the major cloud platforms today, JavaScript is one of the supported languages, including on Azure, which is why I'm here talking to you today. Azure Runtime supports JavaScript, but it also supports TypeScript and any other flavor that you love that transpiles down into JavaScript. And in the words of Scott Hanselman, one of the partner program managers at Microsoft, the cloud doesn't care about language of choice. And one of the best ways to use JavaScript is through serverless solutions. So this conference is all about serverless, and serverless means that the cloud provider, in this case Azure, automatically allocates those machine resources on an as-used basis, and they take care of the services and underlying infrastructure for you. So despite the name, there are servers that are still there, but we as developers don't have to deal with them. So it means you can write and deploy your code without worrying about provisioning or doing the admin and configuration of those servers. And they're inherently auto-scaling, and you only pay based on your consumption, generally depending on how you set it up. This makes serverless solutions very flexible, and it naturally optimizes costs and performance of an application and allows developers to quickly update and release new versions and have a quicker turnaround time to market. And one of the most popular serverless computing is with Azure Functions, Functions as a service. So we've seen a couple examples already today of how you can use Azure Functions in robust solutions, but Functions as a service allow you to execute small, discrete pieces of code. They're focused generally on event-driven execution, such as an HTTP call or a timer trigger. For example, you could have a function that sends out an automated email once a week or generates a report once a month, something like that. And when we're using these Azure functions, they are serverless solutions. And they really allow you to create a simplified serverless backend or API layer for your application. And the good news is that all of these functions can be written in JavaScript. So if you want to get your hands dirty with Node, or you're already a JavaScript developer wanting to have the same language across the front end, back end, you can do that with JavaScript and Azure Functions. So you can have a nice cloud-hosted auto-scaling solution for your application. Serverless and microservices also go together very nicely. Microservices are independently releasable services that are modeled around a business domain. And with microservices, we want them to be deployed independently, which is encouraged with functions as a service. We want them to be small, flexible, and focused on automation, which when we have working with Azure Functions, we know that's what they inherently are. But also to be a microservice, it needs to be modeled around a business domain. So it comes down to how you actually design your serverless solutions. So they go nicely together, but just because you're using functions and serverless solutions doesn't mean you're automatically using microservices. So you have to focus on making those discrete pieces of code aligned to your service boundaries, and that will lead you to a serverless microservice architecture. And this is an example of what that could look like. So I just took this from the microservice, one of the Azure sample architectures, and this is showing a rideshare application solution. And it's using the fully managed services from the Azure Serverless platform. So we have an Azure App Service hosting the application, API Manager, which is exposing the different endpoints and hiding the implementation details. And then we have our Azure Functions for our APIs that are based around different business domains. In this case, it's for drivers, trips, and passengers. And then we're also using durable functions as orchestrator and setting up event-driven messaging service. All these components are scalable and focused around that automation that we want to have with microservices. And most importantly, they can all be written in JavaScript. You can also write it in other languages if you want as well. But this talk is all focused on the cool stuff that you can do with JavaScript. And so you can have these really robust solutions following popular architecture design patterns and taking advantage of all the great stuff that you can do with JavaScript in the cloud. And when it comes to developing these applications and solutions, there are some really good tools and guides out there to help you. If you go to the Microsoft Docs, they have all kinds of quick start templates and learning resources for JavaScript developers in Azure that can help you get started. There's also Azure CLI supports JavaScript, and that'll allow you to create and deploy your JavaScript-based applications with the CLI. Your favorite IDEs, such as Visual Studio Code and WebStorm, also have extensions that let you integrate with Azure and access quick start templates, write, debug, and deploy your code all from within that IDE that you probably already use with your JavaScript application. So let's take a quick look at a demo of what those extensions look like. So I have I've already created a JavaScript function, Azure function, using the templates in Visual Studio Code. So I have the Cloud Tools extension installed. So this is the template that automatically gets generated when you choose Node.js as your language and JavaScript as your language for your function. If I go over to the extension, I can access what I have locally for Azure Functions, but I can also actually see what I have on the cloud. So this is connected to my Azure Cloud instance, and there's a function app that I've already deployed up there, and I can interact with that function from within Visual Studio. So if I wanted to execute this and test it out from my local machine, I can go ahead and do that now. So if we press enter, this will execute. And the template for this one, let's see, we open it here. So it executed successfully. This one, it's doing a hello world, but this one I've said I'm deployed on Azure. So we know it's the one that's on our Azure instance, and it has deployed successfully. I can see if I jump over to my portal really quickly, that's that same one we have here. So this is hitting our Azure instance all from within Visual Studio. So it makes it nice for testing. And if we want to go back to the one that we still have locally, I will close this message. We can run and debug this all within our Visual Studio as well. So if you click F5, you can start running it. And once that's running, you can execute in the same exact way that we just did the one that's hosted on Azure and test it out locally before we deploy it up to the cloud. So I think that might be running. Not yet. What happened? Cool. Well, if it started running, it's being slow, of course. Doing a live demo always makes it a bit slower. But if once you start running, you do it the same way, where you right click and go execute function, and we would see that pop up here. Cool. So it looks like now it's running. If I jump back here and go execute function. and that executed successfully. So if you have some more complex code that you really want to verify and make sure is all working and test it out locally and fix any issues you may have, you can all do that really nicely from within Visual Studio Code. And once you're happy with it, this one is just locally. You can also deploy from within Visual Studio Code as well. You can click the Deploy to Function app, and that'll connect up to your Azure resources that you have and deploy it onto the cloud. So you can deploy it to a test environment. You can deploy it wherever you want before you get started, and you can manage everything that's happening within these tools that we have here. So it's really handy and nice to work with. And all these templates that we get started. So this template that was created is written in Node, and it's based on the language that you choose when you set up your function app. If we go back to my slides. So another really cool thing is the massive suite of JavaScript SDKs. So the software development kits, the libraries that allow you to integrate with all of the Azure services. So Azure has provided us a huge list of all the SDKs that are available. For example, if you watched Anna's demo earlier, she connected to an Azure SQL database, and that can be done from a JavaScript application using one of these SDKs. And actually, her whole example in solution architecture could be written in JavaScript, and she said she had the different language options there. So go check out her code if you're interested in that. But if we look at, if you end up going to the Azure JavaScript page and looking at all the different NPM packages that are available, this is just scrolling through it just to show you how many there really are, because they make it so that you can do all the things that you want to do with your Azure services from within JavaScript applications available to you through Node packages. And to integrate these with an application, all you have to do is run npm install and the name of the package. So this example here is using Azure Digital Twins SDK, which is part of the IoT solution services that are available on Azure. So you can integrate with all different things such as IoT. And once you import that client package, you can create a new client tool, and then you have access to a suite of all the APIs to be able to update the twins, to insert and create and do all the nice things that you would want to do with, say, your IoT digital twin solution. Similar goes for any of your AI and ML packages. There are SDKs available to integrate with those within your JavaScript framework as well. So this is an example of the Azure Cognitive Services SDK, where you can do some computer vision analysis that allows you to analyze images, so you can do some very, very robust things with your JavaScript applications. And another part, this was also mentioned in Anna's app, is of like really cool stuff that you can do with JavaScript in the cloud is with Azure Static Web Apps. So Azure Static Web Apps are a serverless web app hosting service offering, and it's an offering under the Azure App Service, but Microsoft have extended the managed hosting service to automatically build and deploy full stack web apps from Azure from your repo using GitHub Actions or Azure DevOps if you want as well, to seamlessly connect static web apps with Azure Functions. So it's a fully serverless solution. It gives you a globally distributed CDN and a very scalable backend ready to go. And you guessed it, this can all be based in JavaScript. And the static content is JavaScript based anyways, unless you're using like Jekyll or one of those other frameworks. But generally, you have, say, like your React or your Vue app that's transpiled into JavaScript. Then you have your API layer of your Azure Functions, which can nicely be written in Node, and have your end-to-end JavaScript application for that as well. And if we're looking at the Visual Studio tools as well, there's an extension available for you for Azure Static Web Apps that sets it up automatically for you, and that'll automatically create the GitHub action, which helps you quickly deploy your code to Azure. And it'll set up some of the framework and do the same kind of thing that allow you to build, deploy, and debug all from within Visual Studio Code. And the cool thing is, if you do everything end-to-end, say in JavaScript, in Azure Static Web Apps, you can put breakpoints in both your front and back ends and debug them from within Visual Studio. So it's really nice and easy to work with, and really great for JavaScript developers or people who are wanting to work with JavaScript. And it lets you build and deploy everything as one unit. So we mentioned GitHub Actions, so that's part of the solution with Azure Static Web Apps. But it's actually really cool. GitHub Actions is a CICD tool to automate, customize, and execute your software development workflows right from within your GitHub repository. And you can actually even write your GitHub Actions in JavaScript. So if you have custom actions where you're wanting to maybe automatically open up an issue with some information, or just print out certain information in a message, you can use JavaScript to write those custom actions. So the JavaScript actions are just programs written in JavaScript that run based on a specific trigger. And it's a modular piece of code, and you can run it directly on the CI server or the build agent. So they actually end up being faster than container actions, which is the other way of writing custom actions. And because this is all part of the Microsoft ecosystem, it all integrates and works very nicely with Azure. I'm quickly just going to jump over to a GitHub action that was written in JavaScript. So the template for the YAML, you still need the YAML template file, but all it does is you're defining the action, and you're defining the inputs to your function and what that's going to look like. This is just a hello world one. So if we go to our main file, all it's doing is taking in those inputs and having some code there. So here it's just doing a console log. We can do really advanced, fancy stuff, such as connecting to different APIs and, as I mentioned, creating issues and all of that. So you can get really creative with what you're doing with JavaScript. So in summary, we have seen how to create a serverless function in JavaScript, how you can deploy it using your JavaScript dev tools, how you could set up a microservice serverless solution, an example of JavaScript SDKs connecting to a cloud service. We've seen a little bit of the Azure Static Web Apps and how you can work with GitHub Actions as well. And there are many, many things you can do with JavaScript and JavaScript in the cloud. You can expand out into machine learning and AI, and you can even go further into the world of gaming and robots and mobile and cloud, because JavaScript is a very, very powerful and amazing language. There's even been a complete implementation of a Linux emulator written in JavaScript. It can compile C programs, support shell commands, and everything, all based on a JavaScript implementation. There is a concept called the rule of least power from Tim Berners-Lee, the creator of the web, that suggests the least powerful language is suitable for a given purpose. As a corollary to this rule, we get Atwood's law, which states that any application that can be written in JavaScript will eventually be written in JavaScript. So I hope if you're not using JavaScript today, that you go out and learn it. You look at all the cool and awesome stuff you can do with it, especially with the integrations that you can have into the cloud and all the different Azure services, because the opportunities with JavaScript are endless, especially when paired with the power of the cloud. So thank you. I have a link there for all of my slides and resources and the different tutorials and stuff that I used today. And I'll take any questions if we have some time.
Thank you, Melissa. It was a very knowledgeable session. I learned quite a bit from it. One thing I personally like about Azure Functions is that I don't have to worry about any certain programming language in order to start running code on it. With that, we do have a question from one of our audience, which is, what is your preference for the Node.js unit testing framework?
There's quite a different range of frameworks that you can use when you're testing JavaScript in general. So I've used Like Jasmine, you can use that for Node as well. And yeah, a few different ones. But yeah, Jasmine's a really good one.
Thank you. So with that, we have no other questions. So I would like to thank you, Melissa, while we move on to the next session. So moving forward, I would like to invite Patrick, who will be talking about how we can do monitoring with serverless tech. It's going to be exciting. Over to you, Patrick.
All right, great. Thanks, Rahul, for your warm introduction. And thanks again, everyone, for joining today's APAC track on Azure Serverless Conf. There have been some great sessions so far, and it's a good opportunity for us, Azure Serverless and Azure lovers, to get around to share our passion, our experience, and potentially our lessons we learned in using Azure Serverless technology. So my today's topic is I'd like to show you how we can build a dynamic heat map and monitoring dashboard system using Azure Serverless. And coincidentally, I have also prepared a demo that's done in TypeScript. So if you enjoyed Melissa's session about using JavaScript married up with Azure Serverless technology, do stick around, and hopefully you'll enjoy my session as well. A little bit about myself. My name is Patrick. I'm here working at SSW Melbourne. I'm a senior software architect. I see myself as a full stack engineer and public speaker. And a little bit more about myself. I have over 7 years of experience in IT industry, during which I have successfully designed, architected, and led and delivered a number of solutions to a variety of clients in different industries with a focus on fintech. My interest in technologies include IoT, big data, machine learning, AI, and most importantly, Azure and Azure Serverless technology. Over the last year or so, I've been using Azure Serverless technology extensively and helping my client building and solving their business problems and building applications like real-time voice and video streaming, as well as document collaboration. And if you want to find me on Twitter, here's my handle. If you'd like to be a little bit more formal, this is my linking. At SSW, each consultant has his own profile page. You can easily find it by Googling Patrick SSW. And in my spare time, I like to follow and sometimes contribute to some open source projects. I've been recently working on a conversational AI chatbot at SSW Public Repo, which can help you to find an employee in an organization with certain skill sets and availability. So come to my GitHub and check out my activity if you are also interested in AI. At last, there's a technical blog that I sometimes write. I see it as a good place for me to retrospectively summarize the experience I gained or the lessons I learned from my recent projects. All right, enough presentation, enough introduction. Let's look at the agenda. First of all, I'd like to show you and explain why we want to build heat map and dashboard system and why they are a good fit and the key elements in a contact tracing or social distancing monitoring system. And then we'll move on to introducing some Azure Serverless technologies and why I reckon that they are a good fit for us to design a solution to render and deliver our data and convey the information to the stakeholders that they are concerned about contact tracing and social distancing. I'll especially focus on Azure Signal Service and Azure Function. Then we'll move on to a design pattern that comes with Cosmos DB, but often ignored by developers, which is called the change feed and change feed design pattern, and why I believe that it can help us and it's a best fit as the core engine of this heat map and dashboard system. Once we understand all the technologies, then we can bolt everything up to our overall architecture design. And then I'll move on to a quick POC, a demo to show you how we can build this solution easily on Azure Serverless. Right. So as the well-known reason, since the COVID-19 pandemic started, contact tracing, social distancing, and yes, lockdown as well has been the new buzzwords. A lot of great solutions have been invented by technologies around the world to capture the contact tracing history, to measure the social distancing via some smart devices, either a watch or a smart lanyard or band, whatever. Now, we are able to collect the data from different channels like IoT or Event Hub, so on and so forth. Then, how to better visualize the data and serve it to the stakeholders and decision makers to take actions is the next challenge. And mind you, the people who want to look at the data are sometimes from non-tech background. So how we can promptly and attractively render the data in front of them would either help them or affect them in making decisions. A good way, I reckon, to convey the data is via heat map or dashboard. And if we think about that, if we ask a manager at a shopping mall to run a SQL report or to run a CSV report, then it might be annoying. But instead, if we can show a dynamic heat map and dashboard with a real-time updating chart in front of him, he'll tend to be attracted and find the most useful insight as he can. And we want our dashboard and heat map to be real-time. And also, we want the heat map or dashboard to be able to cater for a certain amount of dynamicity in the data, in terms of the types of the data. And why? Because, as I mentioned, we might be able to collect data from different sources, and the technology evolves very fast these days. So if the manufacturer decides to upgrade a certain smart device, then it's likely that the format of the data it collects is changed. So we want to keep the change at minimal level from our end in serving the data. We can make change, but we don't want to spend too much time in making the change. Once we have a nice dashboard system, it can be deployed to either a small venue, like a small company, startup, or a restaurant, or an enterprise level, a big building or a big stadium. Now, here's an example. Aiden is my son who's at his horrible 3, and apparently we are in lockdown, so we're not sending him to his childcare. But the childcare here at Australia works like this. So the kids are usually grouped according to their age, and they will be assigned to a dedicated room. So throughout the day, the kids will spend most of their time in the room that they're assigned to. However, these little creatures are very active. So the exception is that sometimes they want to go to other room to play with their friends or attend some classes. So this would affect the social distancing that we try to apply in the premise of childcare. The management team or the director of the childcare would like to know whether at some point of time, if there are more than, say, 10 people, including kids and educators in a room, and if that happens, they should take actions promptly. They should go there and bring some kids back. Now, so if we are going to build a solution, what we can do? So we need a smart device, of course, to detect how many moving objects, moving human beings in the room. And once we have data, imagine we have the data already, and how can we better render it? Of course, we want to set up a big TV screen on the reception desk and show a dynamically updated chart. So the management will notice that certain room has more than X amount of people, and they will take action. Now, we've understand the requirements. Let's explore some Azure Serverless technologies that can help us to build our solution. The first technology I'd like to bring up is Signal Service. Yes, Signal Service is one of my favorite Azure technologies. So as we all know, Signal library has been very famous among C# or .NET developers, and almost is our default choice when we're trying to build real-time applications on WebSocket. It is great, don't get me wrong. However, by using Signal library, we need to manage the hosting and infrastructure ourselves. If there are tens or millions of client applications trying to connect to our hub that we host on the server, then we need to scale our server out or scale up to allocate more memory or compute power. All this can be done, but all this requires a lot of effort. Signal Service is a great choice in this case. So what Azure Signal Service offers is an abstraction so that you only need to have a turnkey configuration change. You are able to scale the Azure Signal Service up or out as you wish. Azure manages all the rest for you, and you can focus on implementing a logic in Azure Function as a serverless hub. So on the server end, if the Azure Signal service has an increasing amount of traffic, your Azure function can be scaled accordingly. And this all happens automatically. We don't need to worry. So we can focus on writing our business logic, which is great. And once we know how we can broadcast the information to a client application dashboard in our case, we want to find a best choice for a triggering point that we know that there are some data we want to broadcast. And I'll mention the change feed. And the reason why I think change feed is good is that there's a pattern that allows us to use change feed as central data store. I'll expand more about this. With that, let's look at a chart here. So, let's look at a diagram here. So we have our Azure Cosmos DB sitting here. And as I mentioned before, we can have data from different sources injected. And data ingestion is not today's concern, but we just know that we can ingest the data from either your IoT, your big data, your data factory, so on and so forth. Now, once we have the data arrived, change feed comes into play. It's going to capture the change in a document, either a document insertion or update. You might wonder why no deletion. I'll explain that later. But once we have some item appear on the change feed, we can do something subsequently. The first thing we can do is we can trigger an additional call to an external API. This includes Signal service, so that we can do additional things, react on the change on the Cosmos DB container, or we can use Azure Cosmos DB as a intermediate store in your entire data journey. And you might have some subsequent processing or data transformation tasks you want to perform subsequently. Or at last, we can do some data warehousing, like data movement between containers or moving data to Azure Blob Storage for backing up purpose with zero downtime and minimal impact on your live Cosmos DB. So here is the change feed design pattern in summary. It enables us to efficiently process a large amount of data, especially with a high volume of write. That's the nature of Cosmos. So we don't need to do anything in particular. And it is also a great alternative to querying an entire data set to know the change. So traditionally, if you want to know what has been changed among a certain time frame in your data store, what we tend to do is that we will query a snapshot at the beginning of the time frame, and then we will query another snapshot of the entire database at the end time of the time frame, and then we will calculate the delta, the change. It works, but it requires a lot of computation power because we are querying for a snapshot of the entire database. So change feed is a great alternative to this. Every single change within the time frame is captured by change feed. So all we need to do instead is we can accumulate each individual change up, and then it will be our delta. We don't need to do any calculation. We just add them up. That's it. And Cosmos DB is globally distributed, so the change feed is also globally distributed. So as an outcome, we can deploy our subsequent applications, either an API call or another data processing process or a data warehousing task as close to our consumer application or clients as possible. The key benefit of change feed pattern includes following. The first is a perfect as a central data store for event sourcing pattern. So in the typical microservice architecture or event-driven architecture, we will have some type of message queue. Cosmos DB change feed can be a great alternative to a traditional message queue. Why? The biggest benefit I see is that it supports multiple consumer applications subscribing to the containers change feed without any additional work in your infrastructure. So if we take a comparison with Azure Service Bus, if we are to set up multiple subscribing consumer applications in the Service Bus, we need to have a topic and we need to provision multiple subscriptions and allocate each consumer app a subscription. So with Cosmos DB change feed, in comparison, we can simply spin up as many consumers applications as possible as we want. All we need to do is provide it with a connection string, and that's it. And of course, from SpanOps perspective, there's no extra cost to utilize the change feed. Use it or not, it comes with your Cosmos DB engine. So we might as well just use it. If after we've looked at all the benefits, every coin has two sides. There's limitations. So the change feed is not an operational log, meaning that we can capture the change, but if you are looking for a full operational log of your database engine, your data store engine, the change feed is not your good choice. And only the most recent change of a given item is included. What this means is that if for some reason your consumer application somehow could be an exception in your logic or some downtime in your consumer application, that you miss that change item, then it's very hard for you to recapture it. So it's not suitable for application which looks for the ability to replay the past event or some dead letter queue management. So if you're looking for those, you'd better choose a traditional event queue, such as Azure Event Hub or Service Bus or Kafka. And the change feed in Cosmos does not capture the delete. So this is annoying, but there's a way to get around it. The way to get around it is that we can have a isDeleted flag on each document that we store in our Cosmos container. And whenever we try to delete an item, we don't actually remove it from the container, but we set the flag isDeleted to true. So it's treated as a update. So the change is still going to be captured by our change feed, and all our subsequent application can still be triggered as usual. And Cosmos offers a great feature called TTL, time to leave. So when a certain time arrives based on our configuration, the item in the document will be completely removed. So we can leverage that to do the actual delete, whereas we can still capture our change by setting the flag. And in the last, I'd like to touch on the last limitation is there is a guaranteed order in the change feed within a partition key value, but not across partition key values. So if the order of the value across different partition key matters to you a lot in your application, then you need to choose a great partition key. So this topic is quite big, so I'm not going to expand too much on this for the interest of time. So we've understood why we want to use those technologies. Let's look at how we can do it. So how we can read from change feed, there's a push model, as you already seen on the screen. We can use Azure Function Cosmos DB trigger. It comes with Azure Function, and it's no different from other Azure Function trigger. But what it does is that it encapsulates a layer that uses the change feed process library under the hood. So the architecture is very similar to how Azure Signal Service works, that encapsulates the underhood infrastructure management of CNR library. So we don't need to worry about how to scale, how to troubleshoot, all that. So we can focus on implementing the business logic. And the other way around, there is a pull model. What it means is that the client application need to request the change by themselves. There's no automatic polling, so the client application need to manage that by itself. All right, so we've understand why and how. Let's look at the overall architecture. So starting from the right-hand side, we have our data store, which is our Cosmos DB. Whenever there's a change captured by the change feed built in with Cosmos DB, it can trigger Azure Functions Serverless Hub. And Azure Functions Serverless Hub has output binding that broadcasts messages to client application via a typical pub/sub architecture via Signal service. Now, before we allow the connection being established between client application, our dashboard on a big screen with Signal service, there need to be a negotiation/handshake process happen beforehand. I'll show you the code so it will make more sense. All right, so with a quick overview of the overall architecture, let's see things in action. So if we jump to my subdomain, my domain, we can see that I have a colorful dashboard in front of your eyes. And what is more important is that it's being updated in real time without me needing to click any button to refresh. You'll see that when it happens. But let's just have a quick look at this dashboard. We have an x-axis of the timestamp, and we have a y-axis of different rooms in my sounds track care. So we can see that if we hover over any slot, we'll see the number of people in a room. And we can see that in Lion Room, at a certain time, 15:15, there are 15 people there. Oh, so it just changed. So you can see we can even hover over the extreme or high or different category so that we know the urgency of taking actions to either move some keys back or better arrange the classes in the room. Now, this is cool. I built this application with Vue. And let's move on to Azure and quickly give you an overview. So you must have seen all these services before, so I just quickly walk through what they are. So we have a Cosmos DB. It comes with a change feed function, and we have our Azure function, our Signal service, and we have application inside to monitor our application. Easy. Now, if we jump to the code base, what we can see is that, so if we start from the client end, what I'd like to show you is, in order to connect to Signal service, all we need to do very simple. We need to install a package, and we import it as we import any other package. After that, all we're going to do is to instantiate an instance of Signal Hub connection via the Hub connection builder, and we give it the URL. We can grab the URL from Signal service on Azure, and then bam, done. We're all good. And we can define any functions that need to be triggered on certain events. So here, when a new message arrives, we can update our chart. And we can just start the connection, then that's it. So from client application perspective, it's very easy. So if we look at the backend, so what we have is a bunch of Azure functions. I have a data ingester, which is a function that's focused on data and ingest data to our Cosmos DB. But in real life, the data can be from different sources. It doesn't really matter. Once we have the data, we can look at our broadcasting function. So we define an input binding, which is from Cosmos change feed to our application, that if anything changes in my device trace collection, the function is going to be triggered. And we'll also define an output binding with Signal, so that any messages that that's generated and highlighted in the function body can be broadcasted to the clients that's connected with Azure Signal service. So if you look at the implementation, it runs this way. We can get a copy of the documents that's a change being captured in the change feed, and we can do our own data massaging and hydration if we need to, and then we can, via the binding, we can define the signal message and populate it, and that's it, done. So our client application can get the message broadcasted by Signal service. Azure handles all that for us and handles all the connection, and handles all the scaling for us. Now, as I mentioned before, there's a negotiation process that needs to happen beforehand. I haven't implemented any logic here, but if we need to, what we can do is that before we return a connection information and allows the client application to connect to us, we can, because this is a simple HTTP trigger, what we can do is that we can grab some identity information coming from the request, either the JW token or the cookie, and do the authentication and authorization if we need to, before we allow a connection by issuing the connection info. So this way is secure. So as we can see, the program model is so simple. With just a few tweaks here and there, we are able to build a great dashboard system. So if you jump back to my slides, as a quick summary, today I've showed you why we want to build a heat map and dashboard system and how it can help to convey the information and help the audience and stakeholders to better find the insights they're after and take actions promptly if they're concerned about contact tracing or social distancing on their premise. And we've also explored some Azure Serverless technologies that I reckon is a good fit for our solution. I especially focused on change feed design pattern come with Azure CosmosDB change feed. And I also explained why it can be used as the core engine to help us architect this solution. So we look at the solution design, and as part of the software development lifecycle, we've done a quick POC in using TypeScript, married up with Azure Serverless technologies, and prove that the dashboard works. So the management team in my son's childcare is happy. They can watch a big screen and they will be alerted whenever there are certain amount a certain room exists X number of kids and educators. All right, so with that, that's the end of my presentation. I hope you've enjoyed, and any questions?
Thank you, Patrick. I loved how you used change feeds to address an interesting scenario. We do have some questions from our audience today. The first question that we have on the screen is, can you guide us with another example of the benefit of using Cosmos DB change feed in some other types of applications?
Yeah, sure. All right. If I may bring my screen back again, let me try to find the slides where we have the diagram. So let me just load this diagram. So today, in the dashboard system, I mainly use the first route on the top, which is the event computing and notification functionalities. But another example could be the data movement at the end. So as we all know, the partition key in Azure Cosmos container is very important. So if we have a query on our Cosmos DB container against the partition key, the performance is optimal and the cost is the most cost effective. However, sometimes we might want to have some other query pattern. So if we have a person document, and most of the time we might query based on the person's email address because that might be the unique identifier. But sometimes we might also want to query about on the person's first name. Then, if we query using the same container with the same partition key as the email address, then the query will go across different partitions. And that's resource consuming and is expensive in terms of the RU that it consumed, the read-write unit. So we need to pay a lot for that query. So an alternative way to do this is that we create another container with the person's first line as the partition key. And we load the original piece of data there. So we can have different query pattern querying different containers. This way, we can save costs and achieve the optimal performance. Now, how can we make sure the primary container and the secondary container keeps in sync in terms of the data? We can leverage change feed. Whenever there's a change on a person's document in the primary container, we can move a copy of the data across to the secondary container. So the data will be in sync. So your application can still perform the queries using different query pattern. Hope that answers the question.
Yep. Thanks, Patrick. So another question that we have from the audience is there a limit on how many instances can scale up to when using change feed?
Here, I guess the question is about how many instances of the consumer applications.
Yes.
No, there is no limit. So you can have your consumer applications hosted in any type of hosting model, either web app or consumer app or even containerized app. So the scaling is really up to the hosting model that you use in the consumer app.
All right. Thank you. The last question that the audience has for you is, when using the pull model, does change feed copy data mutations across to disaster recovery region?
That's a very, very good question. I guess I need to do some research. Personally, due to the complexity in the pull model, because the clients need to request the change. So to be honest, I personally haven't used the pull model before. So I like to do some research and get back to you. As I mentioned before, you can connect me on Twitter so we can discuss this further offline.
Thanks a lot, Patrick, for the very informative session.
Thank you.
I was going to jump in with a question before Patrick runs away.
All right.
Can we get him back? Or did he go? I'll just go get him. Oh, that didn't work. I was really hoping that transition would work with with the production team, but no, all good. If he does come back, I will ask the question of him. If not, we will carry on. So yeah, I've been really enjoying the content so far. Have you got? Is there anything that's particularly stood out to you, Rahul, in what we've seen so far today?
Yeah, I had a lot of fun learning so much about serverless today, Aaron. More so that I love the fact that I'm not restricted by the choice of programming languages, and I can very easily start building applications and get productive from day one when I'm using serverless infrastructure in my applications.
Excellent. Patrick's back. So we did actually just have another question pop in on the Pubble chat that I'll ask you quickly. It's not directly about change feeds, but a question has come in. Does Cosmos DB support any sort of schema validation of the data structures so that you can ensure that the data that's being sent does match anything that you are that you're storing in your data set?
To my knowledge, I don't think there's any out-of-box schema check on Cosmos DB because it's a nosql, and a typical non-relational database is that you can store any format, and if the format changed, you can still store it there. But in your application layer, you can always do the validation. So, or you can have you can leverage change feed. And you can have an Azure function, subscribe to the change and do the validation there and throw exceptions or alerts if there's any change in the schema. But really, if you choose to use nosql, that means that you want to cater for the dynamicity in the format of data. So you don't want to do a validation unless the change is too drastic.
So
excellent. Thanks for that.
Yeah.
So we hope that you're having fun learning Azure Serverless from the experts today. With that, here's a short message from our friends at Cosmos DB.
Azure Cosmos DB helps you get more value for your money by making it easy to manage the components you pay for, database operations, and storage. The cost to perform database operations, including memory, CPU, and IOPS, is normalized and expressed as a request unit. More request units are charged for more demanding activities. For database operations, you can select one of two models, provisioned throughput or serverless consumption. Provisioned throughput is the capacity you allocate for database operations, measured in the number of request units per second and billed hourly. It works best for workloads that always have some traffic and require high-performance SLAs. If the traffic is predictable, you can use standard provisioned throughput to manually set and adjust capacity as needed. If the traffic is unpredictable, you can use auto-scale provision throughput to instantaneously and automatically adjust capacity between 10 and 100% of your set limit. Auto-scale becomes more cost-effective than standard when traffic is unpredictable and not close to maximum capacity most of the time. Provision throughput may not suit workloads with only occasional database operations and lower performance requirements. These applications can benefit from the serverless model. While it has a higher unit cost, it's consumption-based and only charges for the request units used per database operation. With consumed storage, fees are charged for the total gigabytes used per month for both transactional and analytical storage. You also pay for storage I/O and analytical storage. Get the most value from your workloads by understanding the components you're built for in Azure Cosmos DB.
We've only got one more session for our event today, and I want to welcome to this. I was going to say welcome to the stage. It's been that long since I've been at an in-person event where I'm just not used to the fact that we don't have stages anymore. I would have thought I'd be adapted to that by now. Anyway, I'd like to bring Ezzy up. Ezzy is here to tell us all about, help us navigate this landscape of the various things that we can do with serverless and how we can integrate them all together using the Azure integration application. Ezzy, over to you.
Thanks, Aaron, for this wonderful introduction, and thanks for having me on this show, Azure Serverless Conference. It's a pleasure to be here. So today I'm going to talk about the secret behind building a reactive Azure integration application. And a little bit about me. How am I the right person to talk about this before we get started? I am Mary Caesarian. I'm the lead product consultant of Serverless 360 at Kowai.co. Having said, Serverless 360 is a tool for Azure. So we transform the support for Azure serverless applications across enterprises. And this role gave me opportunity to interact with Azure experts, solution architects across various domains across the globe. And I'm here with some of the interesting learnings that I had in the last 4 years out of my total 12 years of IT experience. So my journey, last 4 years with Azure serverless integration space is amazing. And every day turns out to be new learning. And I'm excited to share some of them with you here. So let us get started with a very basic question. What is a reactive application? When do we call an application to be reactive? So according to the Reactive Manifesto, it is expected to have 4 key characteristics. And first and foremost being responsive. So we all know, right, being the consumers and developers of modern applications, we all need an application which is highly responsive. Let us elaborate this word a little more. So to make sure that we build reactive applications. And responsive system is expected to respond in a timely manner if at all it is possible. So responsiveness is a cornerstone for usability and utility. But beyond that, responsiveness also means that problems may be detected quickly and dealt with effectively. Even before the customer realizes that there was a problem with my system, but my application should restore and respond back to the customer. Responsive systems should focus on providing rapid and consistent response times, establishing reliable upper bounds so they deliver a consistent quality of service. This consistent behavior in turn simplifies error handling, builds end-user confidence, and encourages further interactions. So how can I built a resilient system. So resilient systems should stay responsive in face of a failure. So this applies not only to highly available mission critical systems. To any system that is not resilient will go unresponsive after a failure, which has to be avoided. But how do I achieve resilience? Through 4 critical aspects: replication, containment, isolation, and delegation. Let me elaborate a bit more on all these 4 factors. Failures should be contained within each component. So, isolating components from each other and thereby ensuring that parts of the system can fail and recover without impacting the entire system is very critical here. And recovery of each component is delegated to an external component, which in which case we can ensure high availability by replication wherever it is necessary. The most important point here is your client should not be burdened with handling these failures. My application is expected to be elastic if I am building a reactive application. When I say elastic, this system is expected to stay responsive in varying workloads. So in real-time scenarios, none of my applications get in static or predicted input ranges, and it keeps changing. So reactive systems should react to changes in the input rate by either increasing or decreasing those resources that are allocated to serve these inputs in real time seamlessly. So this implies that our design should have no contention points or critical bottlenecks, resulting in the ability to replicate my components and distribute my inputs among them. So reactive systems should support predictive and reactive scaling algorithms by providing relevant live performance measures. They should achieve elasticity over cost efficiency. And the system is expected to be message driven. So most of our modern applications rely on asynchronous message passing to establish a boundary between the components that ensure loosely coupling. So isolation and location transparency is also ensured with the help of message-driven architectures. So this boundary also provides a means to delegate failures as a messages. So this also ensures a non-blocking communication that allows the recipients to consume the resources when they are active. So leaving the system overhead out of the context. So as all these terms sound complex, is there an support that I get from the application development platforms that help me build reactive applications at ease, which encapsulates all the complexities and lets me focus on my core business need that I would like to achieve? Yes, we have Azure to save us. What does Azure has got to offer to help me build reactive applications at ease, ensuring all the 4 integral principles that we just talked about? I have a complete package of enterprise integration platform services that helps in building reliable reactive Azure integration applications. So, when I bring all of them on a slide, it might sound like I have a huge bunch of resources to pay attention to and to understand. Let me give a glimpse of some of these services which play a critical role in almost industries across domains and enterprises who build mission critical applications. And as we proceed further, I'm going to bring in an interesting use case from a real-time customer scenario, which has been solved with the help of an Azure integration services. So here, the beauty of Azure services that I admire is they fit exactly into your real-time business use case. See, we just talked about delegating failure from a component. So imagine I have certain messages that is coming into my service bus queue that I cannot process at this point in time due to various reasons. That could be system-specific reasons or business-specific reasons. Service bus supports an secondary sub-queue called dead letter queue, wherein I can pile up all my failed messages and I can process them when it is the right time to process. So such features exactly fit into your real-time use cases. take, for example, logic apps, as many of my speakers before me in this conference talked about the capabilities of logic apps, functions, and Cosmos DB. I need not emphasize more how resilient they are, or how capable they are to integrate with external third-party applications seamlessly, and how do they scale on runtime. So all the 4 pillars that are required for my reactive application are majorly taken care of by the cloud service provider like Azure. Now let us focus on our core business. And we are going to proceed with addressing a real-time business need, and we are going to fit in these integration services into the business need to build and complete end-to-end integration application. Let's get started by understanding the business. Imagine this is for an shipping and logistic enterprise who is decided to build an intelligent fleet management system. So they have vehicles taking care of shipments across the globe, and they wanted to make their system data-driven and more intelligent with the help of Azure. So there is a trend in industries adopting to cloud. Like some of them choose to build their entire business application in Azure, but still there are enterprises who choose to retain their legacy code in their premise and integrate part of their application with the cloud services. So here is one such case wherein the customer has their core business logic still existing in their on-premise system, and they want to expose it to the cloud securely and get integrated with other integration services, making use of their capabilities to build a real intelligent fleet management system. So this is the scenario. Let us expand this scenario further by understanding all other requirements that they have. So to get started with, their vehicles are all implanted with telematic devices, and these devices are capable of streaming real-time information, useful information like what is its fuel condition right now, what is the speed at which the vehicle is traveling, what is its live location. All these necessary data is being streamed by these telematic devices implanted on these vehicles. Now, what do I actually need to solve this business need? First and foremost, I need an event ingester that accepts and stores the stream of events. So this event ingester should be capable of ingesting millions of events per second, and it is expected to scale seamlessly with the scale of my business. And I cannot expect my legacy code running on my on-premise application to handle the events as and when they come in. So I need a cloud storage service that will allow my on-premise application to process these events at its convenient time. And how my application, the core business service, is existing in on-premise. This has to be safely exposed to my cloud services. So I need a service in place which can do this job for me, which can expose the service from my corporate network into the cloud securely without inviting much of changes into my corporate infrastructure. And I need a reliable storage option where my business service can process the data and store the persistent informations too, which would ensure the storage is expected to have business continuity guarantee and enterprise-grade security in place. I need an event routing service. So we are creating a reactive application. So I do not expect my on-prem service to look for the blob container for the arrival of the event that it is required to process. So I have a cloud storage service. I do not expect my business service to keep pinging the storage service to check whether the data has arrived or not. Instead, the system should be reactive. That is, as and when an event is available for my business service to process, I expect to get a notification to my business service, which will inform the business service, yes, the data that you are looking for has come in and you can pick it up for processing. That is how I want this system to work. And following the processing of the information, there are certain follow-up operations that needs to be taken care of. And this invites interaction with third-party applications, which are my clients, that needs to be orchestrated and then taken care of as and when data is being processed by my business service. And here I need to make sure that my business service is completely decoupled from my backend follow-up processing orchestrator. So I need to bring in a messaging service that would decouple the follow-up actions from my core business service. So these are my requirements from the Azure integration space to fulfill the business needs of the fleet management system that I am building. What is the next step? Let us now choose the right Azure services to be fit into these business use cases, and let us visualize our business application now. So here is how I have designed the fleet management system, which is partially on the cloud. So I have an event hub put in the place of an event ingester, which is capable of ingesting stream of telematic events seamlessly. And Event Hub has a wonderful feature called capture. So say when we deal with events, there are two critical processes that needs to be taken care of. One is saving the events and then processing them. This Event Hub cuts off the overhead of me dealing with saving the events. Let me show you how easy it is to enable saving of events using an Event Hub. So here is a bunch of resources that I have in my Azure portal to fulfill this business need. Here I have my Event Hub. I have created my Event Hub in the standard tier, wherein the capture feature is allowed, and the basic tier doesn't have the capture feature enabled. So it's just a flip of a button. A toggle button will do the job for me with a little bit of configuration. So the complete saving of event overhead is taken off from me. I can now focus on processing this event, which is my core business service. Getting back to the presentation. So I turn on capture on my Event Hub, which captures the events into a storage destination. So here I have a couple of options. I can choose either an storage account or an data lake storage. So here I have chosen an storage account blob storage. So when I turn on capture, the events that has been received by the Event Hub from the telematic devices is now saved comfortably into my storage blob. Now the next step is exposing my on-prem business service to the cloud. I have put Relay in place to do this job. So Relay can seamlessly get this attained. So Relay is a reliable service that can enable you securely expose your service that run in your corporate network to the cloud, to the public cloud. So this can be done without opening a port in your firewall or making any intrusive changes in your corporate infrastructure. That's the best part. So I expose my on-prem service through Relay. And the next step is to make this whole setup event-driven, which is a key in reactive application. So what is a component that is the heart of my reactive application here is Event Grid. So Event Grid is an wonderful service from Azure, which can seamlessly route events from any services to any service. So you have custom binding possible in an Event Grid topic, and you can subscribe to an webhook in an Event Grid subscription. So this makes pretty much Event Grid and the excellent choice to route an event in any scenario for that matter. So in this case, I have an Event Hub that emits the event to the Event Grid, which says that a capture file is created. And this Event Grid passes the event to the Relay, saying that the file that you're looking for is now available. Now, the on-prem application can comfortably pick up the file from the storage blob and continue with the processing at its own pace. So this part is completely achieved. And next, is an follow-up operations that needs to be taken care of. Yeah, so we have collected a lot of data that has been processed to come up with useful information, and this information has to be passed on to the respective clients or respective third-party applications to react on. So that is where I bring in my logic app, which is an wonderful orchestrated service from Azure, which exhibits a number of connectors, and you can even build custom connectors which can facilitate integration with third-party applications, or a number of built-in connectors would also facilitate building your solution without writing a line of code. And what is necessary here is to decouple the core business service from my follow-up operations, which is defined in my logic app. So I bring in an queue here. So any commands that is expected to be processed by the logic app is compiled as a service bus message, then pushed into this service bus queue, and the logic app, which is listening to this queue, can pick up this message at its convenience and then process it. So as we observe here, we have clearly decoupled all the core components of this business application, ensuring that failure of one is not going to impact the other. The other would continue working without any challenge. So we can make use of the features from Azure, like a geo replication, or ensuring high availability. To ensure high availability, you can make use of dead lettering in the event grid and service bus queues to make it fail proof. And serverless, when we coin the term serverless, it means that seamless scaling. So need not to be sent. You can configure appropriately to make sure that your application is elastic seamlessly. And we have designed the application completely event and message driven to ensure that the components are loosely coupled. So this organization, later I'll also show you a glimpse of event grid in the Azure portal, where then we have an connection to the Azure Relay, which is a hybrid connection because it's exposing an on-prem service. And when this application design is also extendable, say this particular scenario, we later decided to replace the on-prem component with a reliable, durable function. So in this case, this in the inserting and function into a scenario is also can be done seamlessly without impacting rest of your business components. So we understood the business needs, and we have identified the right services to fit into the business scenario to solve the business solution. So what is next is, as we build these services, it's necessary to adhere to best practices. But actually, this topic itself is can run for an hour or so. So I am giving you the authentic reference wherein you can find tips from experts across the world on serverless. So this is a knowledge base that covers serverless best practices, powerful tips, and latest announcements from top-notch industry experts to help you discover new opportunities and save time within the stack. Some of the very common tips would be like, make sure that you adhere to standards when you build your logic apps. Say retry policy definitions or error handling. Make sure you take care of these when you build your Azure services. And extensive knowledge on every service that we are working with will help us use them appropriately. Last but not the least, so we have built a reactive application, and it's equally important to support them in real time. So you need to define a frictionless support strategy to support your reactive integration applications in production. Azure does offer a handful of management and monitoring tool sets that would help us to have a live monitoring of your resources. To add on to that, let us have a look into a typical support scenario in an enterprise business. So I have various set of users who are involved in supporting my Azure application that is in production. So, but when we look The Azure portal access is restricted only to designated Azure experts in an organization, because it's pretty much harmful to give access to support people on the Azure portal. That's how enterprises admit. So when we look at the typical support, how is it split across the members in the team? We find that it requires an good amount of expertise to deal with the real-time support requirements when you are working with a support application. But unfortunately, the business users and L1, L2 support team do not have visibility on the solution that they are dealing with, or there isn't security challenge in giving them access to the Azure portal. And the L3 IT support team was present with a limited experience of the solution. How do we tackle this? So what actually ends up happening is most of the support gets addressed by a level 3 IT support team, and 70% of the supports are being addressed by an experienced Azure developer. What is the harm here is you are investing your skilled Azure resource time into the support tasks. Instead, it should be for innovation in your business. How do we tackle this? So that is where a tool like Serverless 360 can pitch in, and we have brought in an excellent set of tool set that complements the Azure portal by delegating the support tasks to the IT support teams. So we enable the support team with the right tool set that will help them understand the solution that they are dealing with and proactively react to the issues that occur in them. So we can safely offload the support overheads from the Azure experts, allowing them to focus on innovation, hence reducing the total cost of ownership on your application. How in action? Let me quickly give you a glimpse of this. So I just showed you the resources that I created in the Azure portal to fulfill the business need. And I have the same resources represented in Serverless 360 as an application. So when a support person looks at this representation of the business application in Serverless 360, they clearly point out where the problem is. So they visualize the business application, they've identified the issue, they find that the dead letter messages in the queue has piled up. Say if you are not using a premium tier queue, you do not get visibility on the messages in the queue. So that can be addressed with the help of Serverless 360, wherein you get visibility of the dead letter messages, and that can be viewed and processed right from here. So this way, the tool set to fulfill the operational need of an Azure application is provided to the support team. And this can also be automated with the help of automated tasks in Serverless 360. Say any failure in your logic app, that can be spotted in action required, and that can be resubmitted to restored. And any real-time tracking of the business application can also be done with the help of business activity monitoring. So this is how the tool can complement the Azure portal in making your Azure experience much better. Same in this scenario that we just talked about, say business user says that a typical support scenario would look like this. A business user asks, is the follow-up processing broken? I have no idea. Let's raise a support call. We can't see anything. Let's escalate it. This is how the issue gets escalated to the Azure team, and the Azure expert is expected to invest a lot of time in looking into this problem. Instead, when we have a right tool in place, the team can be proactive. They get an alert, they solve the problem even before the issue has been escalated by the business users. So you be proactive and give your customers a wonderful experience when dealing with your Azure application. To summarize all that we discussed today, we understood what are all the requirements of a reactive application as recommended by the Reactive Manifesto, and we understood how to build an application to meet the business needs by choosing the right services from Azure. I gave you the resource link to check on the best practices that you will need to adhere to when you construct your business components. And when you need to define a frictionless support strategy, Serverless 360 is a place to go. So here are some useful links, and thanks for listening to me. I am open to any questions that you have.
Excellent. Thank you for that. That was a really informative session, particularly helping to demystify some of the complexity that we've got around Azure. Unfortunately, we are out of time today, so we don't have any time for questions, but do reach out on social media. But I would like to lastly thank all of our speakers that we had. Give them a big round of applause. And I'd also like to thank my co-host Rahul for jumping in and helping me out with this stuff today. But that's all that we've got. Thanks for watching, and we'll see you next time.